As per the latest trend, Docker is becoming the most in-demand skill for data domain, especially in 2026 because of rise in AI. If you want to just deploy your code, if you want to run open source applications such as Airflow, or you just need to automate some agentic workflows, you need Docker. But data professionals were not actually focusing on this skill till now, and this is the high time to do it. And in order to help you do that, this 4 hours long Docker Masterclass will cover Docker fundamentals, Docker versus virtual machines, virtualization with Docker, Docker images and Docker containers, customized Docker images with Dockerfile, Docker networks, Docker Compose for managing microservices, Docker volumes, Docker push to DockerHub, Docker environment variables, and much more. This is not just a theoretical video. This video is packed with real hands-on where we will be building real world containers. And you know what? Everything is covered from scratch, so you do not need any kind of prerequisite. Plus, all the code examples, notes, PDFs, all the live demonstration, everything is available to you, and obviously in cool graphics. So all you need is just you and your laptop and your notebook to take notes, and that's it. And obviously, hit the subscribe button to get started with this video so that you do not miss any future masterclass that can help you achieve your dream job. So if you have hit the subscribe button, let's get started with this amazing masterclass.
So what's up my fam? How's it going? Are you excited for today's video? Because I am very excited, and I just want to come straight on the point. Docker Masterclass. Why this video is for you? Let's first confirm even this video is for you or not, because I know your time is so precious and you want to do some amazing stuff for this world from your time. Okay, so let's actually discuss why this video is for you, or even this video is for you. If you are a data professional, okay, data engineer, especially data engineers, if you are AI data engineers, if you are AI engineer, if you are data scientist / data engineer, if you are data analytics engineer, in short, if you are a data professional, okay, you are at the right place, because you need to learn Docker, especially for 2026, which is coming very soon in just few days. Why? As I just mentioned in the introduction as well, as per the latest trend, Docker is that skill which every organization is looking for. Why? Because of rise in AI. Not just about rise in AI, Docker was always there, but Docker was not very popular among the data domain. Why? People used to think only software engineers need to learn Docker, only DevOps people need to learn Docker. But with the rise in AI, when you can say organizations are looking for people who can build pipelines, who can build, you can say, end-to-end data engineering workflows, they also need to work with Docker. Why? Because they would need to build AI integrations as well. Okay, even like not even like AI integrations. Even if you just, let's say, want to deploy your code, deploy your endpoint, deploy your APIs that you have built, you need Docker for that. And all the big companies, including top product based companies, you can just search on Google just to confirm this fact, are using Docker. Again, just go to any job description, data engineer, AI data engineer, data science, data analytics, whatever, analytics engineer, whatever, you will find Docker. I was like, yes, data professionals were running away from this particular skill, and I know that it's very important for your growth, for your success, and for your career. Let's try to create a masterclass for Docker where data professionals will run after Docker, because this is a complete scratch friendly, or I will say beginner friendly video. You do not need to know anything, literally anything. So now you know whether you should watch this video or not. I think you have a clear understanding now. Make sense? So in short, if you want to grow your career, especially for 2026, this video is for you. Okay, now let's look at the agenda, because I know you will say, hey, just tell us the agenda as well beforehand, because we are super busy, and then we will decide like if we need to continue with this video or not. Okay, let's discuss the agenda. So this video will cover everything, literally everything. Right from the scratch, we're gonna discuss first of all what is Docker, because my way of looking at things is a little bit different. I do not like ask you, hey, just learn this technology, just learn this technology. I will first of all tell you why you need to learn the technology. You need to have a why before learning anything. So we're gonna talk about what is Docker, why Docker, Docker versus virtual machines, which is a very hot topic. Then we're gonna talk about a little bit more technical stuff, Docker images, Docker container. By the way, I want to just take a pause here because I want to mention that we gonna do real hands-on in this video. A lot of real hands-on. We gonna literally build end-to-end containers in this particular video. But yes, first we will build our fundamentals, because fundamentals are the building blocks for anything, right? First we will build our fundamentals, all the concepts, and then we're gonna start building the stuff. Okay, so we're gonna talk about Docker images, Docker container, Docker ports, it's called port mapping, and then Dockerfile, Docker compose, Docker networks, microservices, push to DockerHub, Docker volumes, bind bounds, deployment, and real world examples. Wow, man, trust me, if I were you, I would literally be so happy after looking at the agenda of this particular video, because this is not just a quick tutorial where I'm just touching the topics from the scratch or just touching very few topics where I will say, hey, I will just touch few topics, that's it, and that's enough for you. No, we gonna touch each and every topic related to Docker with hands-on, with lab, with end-to-end code example as well. So I think this is that type of video that I would wish if I would have got this video. Okay, this is that kind of video. Plus, this is specifically modified for data domain, data engineers, AI engineers, data science, data analytics engineer, whatever. So you do not need to feel, hey, do we need to learn all those web applications in order to do this? No, we're gonna use Python. That's it. Okay, Python, SQL, because this is our stack. So you will not feel like dumb while just watching the video, because we are not going to pick those examples where we are just focusing on Node.js or whatever. Make sense? Make sense? We're gonna use just Python. Okay, so that is the agenda of this video, and I'm so sure that you are so happy. And let me just tell you, bro, this is one of my favorite topics, and I'm so excited to continue with this masterclass. Make sense? Okay, and I know you are also happy. By the way, all the notes, all the PDFs, all the live demonstration, all the code examples, everything is available in the GitHub, because we're gonna look at some cool visuals. We're gonna just look at the cool live demonstration of the things, and I will just put everything in my GitHub repo. Just enjoy. Okay, and before starting this video, can I just take your 1 minute to congratulate my lovely data fam, because they literally do so much of hard work to, you can say, achieve their dreams, and I literally feel happy for them. So I want to congratulate them, and so sorry for not attaching the most latest screenshots, but these are some of the latest screenshots that I have attached so far. I will attach more in the upcoming videos, okay, because I have some DMs and comments as well, so I will attach those as well. But for now, let's congratulate these people, and very happy for you. Trust me, love you, my data fam. Love you from the bottom of my heart. Love you from the bottom of my heart. Okay, so congratulations to all of you. 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 Okay, do we have more? Yeah, congratulations to all of you. Okay, so I'm really proud of you all. Okay, you are making me proud. You are making our data fam proud. And by the way, if you also want to become a part of data fam, just hit the subscribe button right now, because I don't want you to miss any masterclass which can change your career, like in a good sense. Like you can just be placed in your dream company, and you can just get your dream job, whatever. Okay, so if you want to be notified around the videos, just hit the subscribe button and hit the bell icon as well. Simple. Oh, by the way, we have more. So congratulations to all of you as well. And here are my handles. You can just follow me here if you want to. And most welcome my Elveda fam, because they literally love me a lot. And if you are new, if you do not know about me, these are my some handles. And yes, YouTube is here, so you can obviously subscribe to this channel if you want to gain the modern knowledge about modern tools and technologies, modern trends, because we do not need to worry about the outdated technologies. Okay, makes sense, makes sense, makes sense. Very good. So let's get started with the video and let's cover our chapter number 1. So now, first question first, Ansh, Lamba, we know that we need to learn Docker, and we are very convinced, okay, that we need to learn Docker. But just tell us, what is Docker? Now, do you know what? You would have heard about this term a lot, Docker, because Docker is so common, and with the rise of AI, I would say Docker is like even more popular. But you need to first of all understand what is Docker, because see, for data engineers, Docker is not the first thing that you learn in your journey, in your, like, it will not be the hottest topics, okay, among the hottest topics in your roadmap. But do you know what? Sooner or later, you will realize that you need to learn Docker being a data engineer, because we used to think like, hey, Docker is just for the software engineers, Docker is just like something for CI/CD, for DevOps. No, Docker is for developers as well, and you need to learn Docker, especially Docker. Okay, and it was not a very hot thing for data engineers, but now it is a hot thing, because now industry is moving really fast and rapidly towards open source platforms. There are like so many revolutionary applications being introduced to the industry, so you need to use Docker. And obviously with AI, Docker is like must to have skill. So I thought of like, let's provide this knowledge to my data fam. So first of all, I know your question, what is Docker? So in simpler terms, if I just need to code this thing, what is Docker? Docker. Okay, what is Docker? So basically, Docker is nothing but a platform. Okay, just a platform for packaging, for distributing and running applications inside lightweight portable units called containers. Whoa, Ansh, Lamba, I know this is like a very quick definition, but we didn't understand anything. Okay, it's fine. So for example, I said like Docker is a platform for packaging and distributing. So let's say, just forget about this term for now, containers. Okay, just forget about this term. You can just treat it as like a Docker, as a Docker. Okay, so let's say you have developed something, okay, and you want to package this thing, package your application, package your ETL, package your notebooks, Python files, anything, and you want to distribute it to, let's say, other developer. You want to distribute it to maybe to different environment, QA, prod, UAT, whatever terms or naming convention you use in your industry or in your organization. You need to distribute that code, right? So before distributing that code, you need to package your code, right? Exactly. So that is a platform we use to package and distribute the code, and finally run those applications, or basically code as well, inside the Docker. And when we just run those things, we just call it as something called as containers. Okay, but for now you can simply think of it like we are simply running everything inside Docker. Okay, everything inside Docker. Make sense. So okay, we understood this. Makes sense. Ansh, Lamba, why do we need to use Docker? Because Docker is not a very old thing. So people are still building applications, people are still doing their work, but why do we need to use Docker? There are so many ways to package our code, there are so many ways to distribute our code, but why Docker? Why? Okay. Do you know what? When I was learning Docker, I was also very confused. I was like, why do we need to use it? Because see, we are data engineers. We are not like software engineers. We are not web developers. We cannot think of it like Docker the way that they can think. Because they know how to just transport our code, how to just move the code, migrate the code. But we are data engineers. So we need to think of it like a data engineer in order to understand this. So for example, and in order to understand this, I would need to just first of all discuss the problem that it solves. Okay. So let's say, let me just bring the screen here and let's discuss the problem. Okay. So for example, let's say you are a developer. Okay. you are a developer, and oops, let's say you are a developer, okay, and you are a data engineer basically, okay, makes sense, and you are working in an organization, okay, and you are given a task to build an ETL to load the data from, let's say, any source from API, and you need to dump this data into the lake, into the data lake, or in a database, whatever. Make sense? So what you did, you quickly created this application code. See, application is nothing but just a code, right? So you simply developed this code. Let's say you quickly developed this code on your machine or whatever, okay, and you simply wrote, let's say, Python code or whatever code you want to write, okay. So let's say you simply wrote Python code, because Python is really popular among data engineers, or let's say you wrote PySpark code, whatever, okay, Python plus, let's say, PySpark, or let's say Spark, okay, you wrote Python plus Spark code, okay, makes sense, okay, because this is like very common scenario that we just do on a daily basis, okay, makes sense. So let's say you developed this code, okay, and you did it, only you, okay, only you did it. Why only you? Let's say you are the only developer in your current organization, like for that particular task, okay, you did it very, very, very well done, and you know what, your managers are very, very happy. Your managers are saying, wow, well done, whatever your name is, okay, whatever your name is, they are very, very happy, they are cheering you, woo, and all are like praising a lot, okay, makes sense. Okay, so now it's time to push this code to the testing environment, okay, makes sense, because this is a dev environment, right? Let me just draw it for you. So this is basically a dev environment. Whatever you are doing it here is in the dev environment, okay, and you know the dev environment, right? You know the terminology that we use for application deployment, like there are some environments: development, QA, prod, whatever, okay. So I hope that you know all of these. Okay, so now let's say you are in the dev environment, okay, you are in the dev environment. Now you did everything right, everyone is happy, these people are very, very happy. Let's push these dumb people who do not know how to write code, so here. Okay, so this is the scenario. Now everyone is very, very happy. So now the thing is, they say, hey, let's try to promote this application to different environment, okay. So now what will happen, this particular code will be deployed to QA environment, okay, and obviously this is not you. Now this person is a kind of maybe QA tester or any other person. So let's change the color for this. So let's say this is another person and you are not this one, okay, and he cannot develop this, or he is just a tester. So now what he will try to do, he will try to, and let me just write it here, that this is a dev environment, okay, this is dev and this is QA, or you can say prod, same thing, because this is just, we are just trying to see an environment shift from dev to QA. Make sense? Okay, so this is dev environment and this is QA. Okay, now what will happen, this person will try to run your application, okay, and this is a different machine, this is a QA environment, totally isolated, totally different machine. Now this person will say, bro, whatever your name is, this application, so let's say this person is trying to do something with this, let's say this person is trying to use something or do something, okay. So this person is trying to run this application, run this code, and it is not working. Why? This is a common problem that you see on a daily basis, or I would say not now, because we have the applications there to just get rid of it. But this was a very common problem that people used to face a lot. And this is a very common problem, very, very common problem. And this is a kind of our community, developers community used to say this, hey, this is a kind of, you can say jargon, or you can say a kind of saying that they have created, and it's called, it works on my machine. It works on my machine. I do not care about your machine and it works on my machine. So you need to take care of your machine, but it is working fine on my machine. But this is saying, hey, this is not working on my machine. So this is actually right. This is actually right. And this is not working. But the thing is, it's not his problem. It's not his problem, right? This is not working. It's not his problem. But actually, it is not anyone's problem. Okay, who is responsible for this particular problem? No one. Literally no one. Really, yeah. No one is responsible for this particular problem because this is a problem which is so common that it can happen. Okay. So how we can just get rid of this problem? So this problem can be solved with Docker. Okay, how it can just solve this problem? So in order to see like how Docker can solve this problem, just behave like a Docker, or let's say just behave like a person, just behave like a critique. What are the reasons behind the problem? Okay. And I know you are a great critique. So let's say, let's write down the problems, like what can be the problems, right? So let's say problems will be, let's say, so very common problem will be, let's say, I am using Python version, let's say 3.12. Okay. The other person is using a different Python version. So problem number one, I am using some libraries. Okay. I am using some libraries, obviously. And the other person forgot to add that library, or I forgot to mention about that library. Some runtimes. So whenever we use, let's say, like Spark runtime, Spark version, Spark, you can say, I'm talking about open source Apache Spark version. So I'm using, let's say 4.1, the other person using 4.0, the other person using 3.4. So they can be like so many mismatch. Now just tell me one thing. Can you blame someone for this problem? Can you? Just tell me this thing. Obviously not. Obviously not, because this is not his problem. This is not his or her problem, but this is a problem that can arrive very naturally. Make sense? So in order to get rid of these things, we do not need to blame anyone. We need to find the solution. And the solution is none other than Docker containers. Okay. Docker containers. So now what this will do? Do you know what it will do? So basically Docker containers is a kind of package. Okay. Is a kind of package which will package everything. For example, let's say I am creating a package for my application. So what I will do, I will simply create a package. Okay. So I will note it down what I want. I want, obviously my code that I have written. Okay. I want all the Python versions, exact Python version. I want all the libraries. I want all the exact runtimes. I want all the applications. For example, MySQL, PostgreSQL, any data lakes if I'm using, all the applications as well. Okay. Applications. I want exact port mappings as well. Everything. Like I'm creating a package for my application. Are you getting it? I'm creating a package. So now this time I will not only create this code. No, I will create everything. So let's say let's say you are a developer because you developed this. Okay. I didn't develop this because I would have used Docker if I am developing that. And now you will also know like how to use that. So let's say this is you and you developed this thing. So now this time, instead of just developing the code, you will package your code inside the Docker container. And what will be the benefit of it? You can share this container, this whole container, with anyone else. With, let's say, this person who was crying, hey, it is not working on my machine. So you can just share this thing. Now this time, the person will not say anything bad. The person will not complain. Why? Because everything will work fine, because everything is there. Because see, you are running the entire container on your machine, and if it is running on your machine, it will obviously work on his or her machine as well, because you are running the whole container. You are not running just the code. Make sense? Make sense? Make sense? Everyone, see the power of Docker. See? And I hope now these people will be like cheering up for you, because these people will say good if you just developed something. These people will say bad, hey, why it is not working, it's your problem. Now if you just solve the problem, these people again will say, wow, good job. So just ignore these people and just focus on your development. Okay, focus on your development. Be a good developer. Okay, these people will just cheer it up for you no matter what, because temporary stuff. Make sense? Okay, I hope this is clear. Now this is a very high level overview for those who already know a little bit about Docker, who will say, bro, we do not use containers, we use Docker images. So just hold on, because we are just trying to learn step by step. Okay, and I do care about my data fam. I need to explain everything from scratch, so do not feel like hey. So just keep your mouth shut. Okay, so now what we need to do, we will actually see something. What some amazing things that we have done. So basically one thing is clear, like why do we need Docker? Okay, because you know what, in order to understand Docker, you first need to understand the problem, then you will understand Docker. Okay, makes sense? So basically, in short, Docker is a kind of platform which will help you to do the lift and shift. To do what? Lift and shift. So let's say this is your application. Okay, so let's say this is your application. So now what you can do, you have developed this in dev, you have developed this in dev, okay, dev environment, and you can move this thing to QA or prod or whatever. Easy lift and shift, easy, no need to worry about anything. QA or let's say prod, easy lift and shift. Make sense? Dev, QA, prod. So it can be easily lift and shift, very easily, like piece of cake, easily. Make sense? Because you are simply lifting and shifting the whole container, not just like few code, dependency. Oh, I forgot to add this dependency. Oh, I forgot to add this library. I need to do everything again. No. You do not need to do this. Make sense? Make sense? So that is why Docker is very important. Docker container is very, very important, because if it will not work on your machine, you need to fix it on your machine, and you need to fix the container. Once it is fixed, then you will just move the container to the different machine. That's it. Simple. Make sense? Very good. So now if someone asks you this question, hey, why do we need to use Docker? So you do not need to say, and like behave like a lost person. Okay. Just say, we know that what is the problem it is trying to solve. It is trying to solve the problem is it works on my machine. And it's a very common problem, and it's a very popular jargon. If you just hear this, just do not feel like, hey, what is that? So now you know. Okay, makes sense? And yeah, it makes sense, and it will make more sense when I will just showing you the code as well. It is just like the high level overview of everything, just to make you understand the concept of Docker. Instead of just directly jumping on the code, you need to first grasp the concept. Why do we need to learn Docker? Okay, makes sense. And you already know how we simply solve this problem, Docker and works on my machine problem. And do not worry, I will just upload this particular notes, okay, on my GitHub repo. You can just download. I will upload this PDF as well. I will upload the whatever I'm drawing, whatever I'm illustrating live in that whiteboard or blackboard. You will get that as well in my GitHub repo. You can just simply go and enjoy. Do not need to worry at all. Okay, makes sense. By the way, that is just an illustration for the white and blackboard, but yeah, you can easily use this PDF for your notes. Make sense? So now let's try to look quickly packaging with Docker. We have already discussed this, but you need to get this part again. Packaging with Docker. Docker container includes your code, Python engine, libraries, dependencies, environment variables, OS level settings. That means operating system level settings. Make sense? I added this in my notes so that you can take notes, because it is very important. Packaging is the backbone for Docker. Because see, how you can just solve that problem? By just packaging the resources that you need. Make sense? all the resources. How it does that, we will just talk about that as well, don't worry. But yeah, you need to understand this thing first of all. Okay, very good. Now let's talk about Docker container. Container. Remember, we heard this word in the beginning, Docker container. Whenever we talk about Docker, we 99% of the time talk about Docker container. Okay. What's the difference? See, Docker is the complete application, or I would say more of a type of framework. Not a framework, but yeah, it's a kind of, you can say, complete package, complete application, or you can say a software that we just use, Docker. But within that, we have the core concept called Docker container. So whenever we say we want to package something, we want to lift and shift something, we are saying that we want to work with Docker containers. Containers are the backbone for Docker, for lift and shift. And what is the backbone of Docker container? We will just talk about it. But for Docker, Docker container is the backbone. Make sense? So what is so special within this Docker container? See, container is a lightweight, isolated box that runs your app with. Okay. Basically, let's say you are running an application. Okay, you are running, let's say, simple Flask application, and don't worry, I will just show you some basic applications as well, because with the rise in AI, you need to build some APIs as a data engineer. You cannot say, hey, I am not a backend developer. Hey, I'm not a this, I'm not a that, bro. Just grow up. Okay, I will just show you all the APIs as well, don't worry. So basically, let's say you are running a Flask application or any application, fast API, Flask API. Flask is like very simple, so we can just get started with Flask, and eventually you can learn anything. Whenever you are just let's say running Flask, okay, so you do not want to run it on your machine. Okay, you can run the same application in the Docker container. But Ansh, Lamba, Docker container will be running on our machine, right? Yes. So Flask application will also be running on our machine, right? Yes. So how is it isolated? That is the power of container. Flask application is running inside the container. Okay, is running inside the container. Make sense? Okay, so far, okay. But it is not directly running on your local host. It has its own isolated space where it runs that application. That is why I have written, they have their own file system. File system means all the folders and everything. They have their own dependencies. That means the dependencies of your local machine will not be conflicting with the application or code that you are running in the Docker. They have their own processes, but the cool thing is shares the host OS kernel. That means the OS kernel, that means operating system kernel of your machine. It can be Mac, Windows, Linux. It will share that. It will not have its own OS kernel. It will share the same OS kernel. That is the, you can say, secret sauce of Docker, why it is so lightweight and why it is so easy to work with. Because you do not need to worry about OS. You do not need to lift and shift the whole operating system, which is a very expensive process, right? Make sense? Okay. So for example, let's say you are developing a Flask application. Okay. So let's say you are developing a Flask application. Let's say you are a developer, cool developer, and you know everything because you have studied everything. So let's say you are a developer. Okay. You are a developer. Okay. Now you are developing or basically running a Flask application. So let's say this is your Flask application. Okay. Makes sense. This is your Flask application, and let me write Flask application. Okay. Makes sense. So this is the Flask application, and this Flask application is running inside a container. Okay. So let's draw a container. Let's say this is running inside the container. Okay. So let me just call it as container. Make sense? Good. So this Flask application is running inside the container, Makes sense. Now where this container is running? This container is running on your machine, on your laptop, computer, right? Okay. Okay, makes sense. Makes sense. So let's say this is running on your computer, on your laptop, whatever you want to use. Okay. Let's make it thick. Okay, perfect. So let's say this is running on your machine. Okay. So now what will happen? Even this particular application, this Flask application is running on your machine. I know this, but it is isolated with this container. Wow. This Flask application is running inside your machine. I know this is your laptop, this is your machine, but it is isolated with this container. So we can say that it is not directly running on your local machine. It is running inside the container, which is an isolated layer. The good thing, this container will run on the same operating system that you have on your laptop or machine. Let's say this is Windows laptop or whatever, or let's say Mac, because I don't want to hurt Apple users. I personally do not have Mac, and to be honest, I do not even know how to use Mac. So if I know, that is a different thing, but I do not know how to use Mac, so I cannot say like Mac is bad, Windows is good. So yeah. Yeah. Common thing, bro. So let's say Windows or Mac. Okay. So whatever OS you have, containers do not need to worry about that thing. Why? They do not actually care. They do not actually care. Because they do not need to use any kind of specific Windows or Mac. They just need to use the container itself, and container will hold the application code. It will hold all the dependencies. Now just tell me one thing. Python is Python for Mac and Windows. Let's say a library called pandas is same for Mac and Windows. If you have some data that you are using, it is same for Mac and Windows. So container actually doesn't need to worry about anything Windows or Mac. That is why it is the perfect choice for lift and shift and for packaging the application. That is your Docker container. It is like an isolated chamber, isolated box, isolated container in which you have put your application. Make sense? Very good. Now you will say, Ansh, Lamba, do you know what? We are very smart. I know this. We are very smart, and you know what? This problem is actually solved by whom? You. It is actually solved by virtual machines. Long time back we got Docker. So Ansh, Lamba, why are you promoting Docker? Why? Bro, I'm not promoting Docker. So yes, you are right that virtual machines actually solve this problem long time back, even before Docker. You are right. And virtual machines do actually the same thing that we want to do. We want to simply create a virtual environment. Okay. So now what are the virtual machines? If you just look at the architecture of the virtual machines, if you have some knowledge of virtual machine, like what it is and what is the architecture of it. So first of all, you will get the computer. Okay. You will get the computer. So let's say here is your computer. Okay. Okay. This is your computer. Okay. Now after this, within this computer, you will have something called as host. OS, same thing, operating system. It can be like, let's say Windows, Mac, or whatever. Okay. It can be anything. Make sense? So let's draw this arrow. Okay. So we have this. Okay. Now within the operating system, what you will have? You will have one more thing, which is called hypervisor. Okay. Hypervisor. Okay. Now what it will do? It will simply allow the virtual machine OS to connect. Okay. That means this is your operating system, the original operating system. Let's say you are using Mac. Okay. Because you are like modern developer, so you love MacBook Pro, M5 chip, whatever. Okay. So let's say you are a Mac user. Okay. And you want to develop something, and for that you want to install a Windows virtual machine. So you have the liberty to pick any kind of operating system. So what you will do, you will simply install a new operating system, and it can be same, it can be different. It's not a big deal, to be honest. Okay. It can be same, it can be different. Okay. So these are like virtual machines. Okay. So here you will be having guest OS. Okay. Here you will be having guest OS. Okay. Makes sense. Now within the guest OS, it can be again anything. It can be Windows, Mac or Linux. Within this, you will be having your application running. Oh, there's a long process. So here you will run your application. It can be, let's say, Flask. Okay. Because you want to isolate this thing, right? So this was the traditional way to do it. Okay. Makes sense. So this is the pure, you can say, virtual machines era, when we have virtual machines. Makes sense. Okay. Do you know what happened after virtual machines? This process was like very expensive. Very expensive. In order to isolate something, we were like supposed to do the whole operating system lift and shift, which is not like a very cool thing to do, which is not a very easy thing to do. So now after Docker, what we got everything same, but we do not need this hypervisor. We do not need this guest OS. We do not need a different operating system. No, bro, we do not need this. Do you know what we need? We just need a Docker engine on our operating system, and that's it. We just need what? Docker engine. Okay. We just need a Docker engine on our system, and within that Docker Docker engine. Okay. Within the Docker engine, within that Docker engine, we can run our container. Okay. And that's it. And within that container, you're running your application. Simple. Nothing, anything like suspicious or whatever. Okay. So this is your Docker. I hope it makes sense. So why virtual machines, I know, were there, and virtual machines actually solved this problem before Docker, but still Docker is like the topmost priority right now because of its easy lift and shift, because it is not very expensive. It is not very expensive because you do not need a dedicated operating system for that. Okay. Makes sense. So for example, just to talk about some analogy, and let me just arrange it better so that you guys can take notes, or it's fine like this. Let's say like this. Okay, let's move it here. Perfect. So here you can see like sideways comparison. It will be like better for you. I hope so. Makes sense. It looks cool, man. Yep. Okay, perfect. So now you know this thing. So if you just want to also understand it through an analogy or analogy, whatever you say. So you can think of it like this is a complete apartment, or you can say an apartment. Let's say there's a building. Okay. And building is your machine. Building is what? Your machine. Okay. The whole building. So virtual machines are like apartment within the building. Make sense? Apartment within the building. Okay. Makes sense, because apartment will have its own water supply, It depends, by the way, depends upon which building you're living. But for example, in most of the scenarios, apartment will be having their own electricity, on water, on heat if you are living in cold region, okay, otherwise own cooling system, whatever, and own everything, right? Everything is separate. But in case of Docker, it's a kind of shared room within that apartment. Let's say shared room in the building or whatever, shared room or in building or in apartment, whatever. So let's say, so for example, see, I was an international student, okay, like I came here in Canada as an international student. So initially, like let me not talk about myself because, okay, so let's say there's a student, let's say, and the student is going to IIT, okay. So initially the student is sharing the room with someone, or let's say the student is in his or her own room, but that room is being shared among the whole area. The water supply, electricity bill, whatever is like shared among that particular space, right? They cannot say electricity bill for this room is different, electricity bill for this room is different. No, it is shared. But in terms of apartment is like totally different, because you need to pay your own electricity bill, you need to pay your own water, heat bill, whatever you want to pay. So it is the same analogy here. Makes sense? I hope it makes sense. This is my own personal analogy, but I think it can work here. Okay, so makes sense. So now you know the difference of like why do we need to use Docker container and why we do not need to use virtual machines, because virtual machines are heavy and it is like a full computer inside your computer, because it includes everything: operating system, kernel, RAM, drivers, applications, everything. I know this was a little bit detailed illustration of Docker concepts, but you know what? It is the backbone and it is the fundamental. If your fundamentals are strong, you can become a better developer. You can better understand the technology. If your fundamentals are not very strong, you will get a shallow understanding and you will just get a like workaround understanding, and after some time you will forget it. So always put more efforts in the illustration part. And my data fam actually loves this thing, but there are like 1 to 2% people who say, hey, he's just saying so much of things in the introduction, hey, he just wasting time, whatever, blah blah blah. See, I just say 3 words: God bless you. Whatever I can say. Okay, so it depends upon your attitude. It depends upon like who you are and why you are learning. Okay, some people are just learning to just highlight that skill in your in their resume. Some people are genuinely learning so that they can become a better developer and build a better future. Okay, you're not learning Docker again and again. You're learning only one time. Learn it like a pro, bro. Makes sense? Okay, good. So now we have a clear understanding of Docker, why it is important, why, like how it is different from virtual machines, everything. Now let's try to go deeper and deeper and deeper. Okay, let's do it. So now let's try to talk about the backbone of Docker. And I can say, like, whatever we have discussed so far, we need the working components, right? Like how we are just doing all of these things. For virtual machines, it makes sense. We simply install the virtual machine on our machine and we just build everything inside that virtual machine within that software called VMware, whatever, and we do our stuff. That makes sense. But how we can just create the isolated layers, containers within our machine, and how everything is just like being done? Okay, so there are 2 components, the major 2 components that you need to understand in order to understand Docker. Okay, and this is the most confusing one as well, but do not need to worry, I will just make you understand. Now, what is an image? Okay, because you will say, Ansh, Lamba, I already know what is a container, so I don't need to understand what is container. Just let me understand image. Okay, very good. You're smart. So basically, let me just go to my favorite board, whiteboard, blackboard. Okay, so let's talk about the images. So first of all, what are images? Remember our example where we were just supposed to build our Flask application, remember? Very good. Let's try to take that example. So for example, let's say you are just trying to build a Flask application. Okay, and you want to, you have just completed the deployment, like you have just completed the development. Okay, now it's time to lift and shift that application to the different environment. Okay, and now you want to use a Docker for that, because Ansh, Lamba, you said that it is a perfect tool, so let's try to use it. Now I said that you need to create a container, Docker container, in order to lift and shift the application. Agree? Very good. What is a Docker container? Docker container is an isolated environment where we just create our application. Very good, very good, very good. But just go a little bit deeper. Docker container is nothing but the isolated running instance of your application, right? Let me repeat. Docker container is nothing but the isolated running instance of your application. Okay, so for example, let's say you have this Flask application. Okay, let's say you have this Flask application and you have built this Flask application, and you know, in order to build this Flask application, what do you need? What do you need? I need Python, obviously. Okay, I need Python. I need libraries, Flask library. Okay, at least Flask library. So that means I would need libraries. Okay, I need, let's say, that's it. My Flask application, very simple, simply displaying some text, and that's it. I need at least these two things, right? Makes sense? Okay, very good, very good, very good. That's all I want to know. Okay, so I need these two things, right? Okay, I need these two things with this application. Makes sense? So let me just expand it. This is my Flask application. Okay, this is my Flask application. Very good. Now I want to run this Flask application inside a container. Makes sense? So what I will do, I will create a container. It will be a Docker container. Makes sense? Very good. This is my Docker container. Okay, this is my Docker container, and I want to run this thing. What is this thing? This is my application. Makes sense? Very well done. That's all you need to understand. Very good. So what I did, if you closely observe what I did, this is my original Flask application that I built. Okay, this is my original Flask application that I built. Okay, too thick. So let's say I built this application. Make sense? Okay, good. I built this application. Okay, now I'm ready for it to go to the QA environment or prod environment. Okay, I built this particular ETL, and I have built this, let's say, a kind of anything. See, anything. API is nothing but just a kind of interface between your data and whoever is requesting your data. Let's say you have built this particular ETL thing on, let's say, if you hit this endpoint, that particular endpoint will trigger your ETL and will do the stuff. Common sense. Okay, that's what like data engineers can do. Okay, at least today. Okay, so let's say you have developed this Flask application. It is running fine on your machine. Okay, very good. Now you want to containerize it. Containerize it means you want to package it. What you will do? You will package everything. You will what? You will package everything. This is a package. Okay, you will first of all package everything, and you will create a kind of package, a kind of, you can say, instructions that, hey, this is my Flask application. It requires Python. It requires libraries. It requires this. It requires that. It requires blah, 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 whatever. So you will set the expectations. Okay, that my application needs these much of things. When you have everything, you will create a package. Okay, this is a package. Very good. You have created this package. Okay, you have created this package. Now this package, if I run this package is here. If I run this package here, that means this is my container. Again, wait, this is a package. This is just a package. If it is not running, it is just a package. If it is running inside an isolated layer, it becomes container. Oh, so container is not a container until and unless it has something to run. Okay, it has something to run. Container is not even a container if it doesn't have anything to run. If it has anything to run, it becomes container. Okay, that makes sense. But Ansh Lamba, what is image? What is Docker image? Okay, now you will understand it very quickly. Remember, we created a package. Remember, we packaged our application. This is called image. This is called image. This is a Docker image. Oh, okay. This is what? This is your Docker image. This package. This package. This is your Docker image. Okay. Makes sense. This is your Docker image. Okay. Makes sense. This is your Docker image. Now this Docker image is actually running within the container. This Docker image is actually running within the container like this. Perfect. Makes sense. Okay, this is the perfect illustration, I think, so far. So whatever you are developing, when you create a package that you need Python, you need libraries, you have your Flask code here, everything is packaged together, it becomes an image. It becomes an image. That image, when we run inside the isolated layer, it becomes container. So that is why you will also see this line written in so many places, and it is 100% accurate. Docker container is just a running instance of Docker image. Make sense? Just read this line and you will feel it. Docker container is just a running instance of Docker image. Agree? Agree? It is like very straightforward. Very straightforward. Make sense? Make sense? Docker image is nothing but just a running instance of Docker image. Docker container is nothing but just a running instance of Docker image. So what did I say in the beginning? That backbone of Docker container is just this image. Because whatever you want to run, you need to package. If you can create a correct package, it will run fine. If you create, or let's say package with mistakes, and if it has some bugs, it will not run fine in container. Wow. Literally wow. And do you know what? This is the thing that gets shipped to different environments. So let's say this is your dev environment. This container is running in the dev environment. Okay. So let's say this is dev environment. Okay. Now what you will do, you will take this image, you will run this image in the dev container. Container is nothing but just the running instance. Let's say there's a plug. Okay. There's a plug. You simply switched on the plug. That's it. That becomes container. Okay. Makes sense? This is a Docker image. You packaged everything. You turned on the switch and it is now running. It becomes container. And this container is running on your machine, which is the dev environment. That is running fine. So if it runs fine on dev environment, you will take this image and you will use this image now to ship it to the QA environment. Okay. QA environment. Now just tell me one thing. What is the difference now? What is the difference between this and this? Nothing. Zero. Zero. Why zero? Why zero? Because container, what is a container? Container is the running instance. Now, if let's say I ship this image, let me just write ships to. Okay. If I ship this image, the same image which is running in the dev environment, if I ship this image to the different computer, different machine, different whatever you want to say, will it create any difference? Obviously not. It will run exactly the same because that Docker container is nothing but just running or turning on the switch. That's it. And what's the big deal to turn on the image? You just need to hit the turn on button and that's it. If you are on Mac, doesn't need to worry about anything. If you are on, let's say, Windows, same thing. If you are on Linux, same thing. It doesn't need to worry about anything. You just need to turn on the image. That's it. This is the concept of an image and container. Of an image and the container. Now let's talk about a very important concept called layers. And this concept goes very well hand in hand with Dockerfile as well. And after that, we're gonna simply directly jump onto the lab part where we'll be just doing so much of stuff. And we will not be just discussing about these fundamentals, because we have discussed about these fundamentals in very much in detail. And you can see, we are discussing everything like live, drawing everything. I'm literally drawing everything in front of you that you can just understand and feel it. Okay, so there we will simply do the hands-on. Okay, very good. So now one important thing. Now you will say, Ansh, Lamba, we understood this thing. Now, can you please also tell us like how to create this image? Let's say I created my Flask application, I created my Fast API application, I created my ETL, but how to create this Docker image? Okay, that's a very good topic. Okay, so let's talk about that thing. So let's say you want to create a Docker image, right? In short, you want to create a Docker image. Okay, now there are two different ways to create the Docker image. Okay, there are two different ways. Okay, let's talk about the actually let's talk about both. Okay, so let's say this is one Docker image, not like one type of Docker image. Okay, makes sense. So this is one type of it, and this is second type of it. Okay, what I'm doing? Okay, perfect. Let's use this one. This is better. Okay, so these are two different kinds of Docker images, two different types of Docker image, whatever you want to say. Okay, two different types of Docker images. Now, if we just talk about the first type, which is the backbone, or I would say which is the most widely used one, okay, it is also called as Dockerfile. Dockerfile. You would have heard about this term, I am so sure, Dockerfile. Because if you do not know about Docker, and if you just go to any new web page where you just want to use the services, they will simply say, hey, just get this Dockerfile and you will get everything. So this is the concept. Okay, so what we do in Dockerfile works in the layers architecture. What do I mean? So let's say you want to run the Flask application. What do you want? The basic thing, the non-negotiable. What? Python, obviously, Python interpreter, right? So now you do not need to install the Python interpreter on your machine. No, because let's say you are just containerizing this application and you need to ship this application to a different computer. Will you expect this from that person that, hey, you need to install this Python? No, we will install everything. So what we do, we simply use a kind of base image. So second type of image is base image. Let me just write it here. So second is base image. Now what happens? So in Docker, or you can say in Docker community, in DockerHub, we have images, pre-built images for everything. So let's say if I want to use Python, there's an image for it. If I want to use, let's say MySQL, there's an image for it. If let's say I want to use any other application, let's say MongoDB, I have an application for it. And nowadays we even have like applications for LLMs. If I want to use, let's say Olama, I have an application for it. So I do not need to install anything on my machine. That is cool thing. Okay. So what I do, let's say I want to use Python. Okay. I want to use Python. So what I will do, I will simply pull Python base image. Okay. What I will do, I will pull Python base image. Okay. This is my step number 1. Okay. I will pull Python base image. Okay. Then after pulling this image, obviously I need to do something. What? I need to write my code, right? So what I will do, I will copy my code, whatever code I have written in my local machine, in my VS Code, in my file system, I will copy it. So I will simply say, copy my code. Okay, it will copy the code. Then I want to install some dependencies, right? So what I will do, I will install all the packages. Let's say requirements.txt file, if you all know about this. So we create a file called requirements.txt, which will take care of all the packages. Let's say I want to install NumPy, Pandas, Flask, all the things. So I will simply say install dependencies. Okay. Or let's say install libraries. Okay. And then at the end, run my application. Simple. So what you did, you created layers. You created what? You created layers. See, this is the first layer. When you simply imported it, then this is the second layer. This is the third layer. These are the 3 layers that you have created. Ansh, Lamba, there's a 4th one as well. Bro, this is not a layer. You're simply saying, hey, run my application. So you created these 3 layers on top of for your application. Okay. Because obviously if you just want to create an image for something which cannot be like used directly. You cannot use Python directly, right? We can. Okay, run the Python application without the code. What will happen? Nothing, bro. So you need Python. Then you need to copy the code that you have written. Then you need to install the library so that your code can be run easily. Then you need to run your application. Make sense? So everything starts from base image. You cannot do anything without base image. Anything. And this base image is here. This base image is here. So here you simply pull base image, that's it. Now you will say, Ansh, Lamba, if we cannot do anything with the base image, why do we need to pull it? Bro, it depends. So let's say you want to use MySQL database. You want to use, let's say, data lake, anything. Let's take an example of MySQL for now. Let's say you want to use MySQL. So in case of MySQL, you can simply use a MySQL without copy your SQL scripts, right? Because maybe you need just empty database. You just need like everything empty. You do not need anything. So in that particular scenario, you do not need to create a Dockerfile. You do not need to make changes. You do not need to make the layers in your image. You can simply pull the image and that's it. So in short, we do not create images. We use base images directly, or we make changes to the base images. We do not create our images. No. Yes, we can create our own images as well. I will just let you know after some more sections of this video how you can create your own customized base image. Okay. And you can just push it to your DockerHub as well. And I will just show you how you can just do that. And I will push my own image as well. And you know what? You can also download it. So we will have a lot of fun. Don't worry at all. Okay. So this is the whole concept of images and containers and the types of images. We have Dockerfile when you want to do the customization, and we have the base image when we just want to use the pre-built image, and that's it. Make sense? I hope it was a good section, bro. Nice, nice, nice. I'm loving this particular video. I'm being very honest because I love Docker. I personally love Docker. And to be very honest, I also didn't learn Docker in the beginning of my journey. I learned Docker after, you can say, learning so many other technologies as well, because you as a data engineer do not need to learn Docker in the initial stages. And this was a criteria, I would say, few years back. But now, even if you are in your initial phase of data engineering, you have to learn Docker, because every other technology is dependent on Docker. For example, let's say I got so much request. I get so much request for Airflow. Do you know what? You cannot use Airflow without Docker. You cannot. It's like next to impossible thing. You cannot install all those things in order to run the Docker, in order to run the Airflow. So you need to know all of these things in order to work with the modern tools and technologies. And with the AI, you need everything to be done using Docker. Make sense? And yes, Docker is being used in so many top-based product-based companies. So top product-based companies. So you need to know this skill, and just go to any job portal, just search for the data engineer role. You will find Docker in 90% of the job descriptions now. It was not the scenario a few years back, but now it's everywhere. It's everywhere. Even if you are not a DevOps engineer, you need to know Docker. Docker is not just for DevOps people now. It is for data engineers as well. Make sense? I would say it is for AI data engineers now, and it's my responsibility to tell everything related to AI data engineering. So yeah, Docker video is here. Just enjoy. And if you are loving this video, just do let me know in the comment section, because I am loving and I'm just loving and I'm enjoying recording this video, to be very honest. Okay, so let's see what we have next. So here comes the main part and I'm not kidding, bro. Docker installation. Do not be in rush while installing Docker. Otherwise, do not complain. Docker is not running, Docker is not running, Docker is not running. Do not be in rush. You need to go step by step very carefully. And trust me, it is not an easy one. But thankfully, we have so many videos available to install Docker. And yes, that is the best part. So I would recommend to just use any resource to install Docker. And if you already have Docker installed on your machine, I think that's the best thing. Even if you do not have Docker installed, do not worry. I will just tell you step by step approach, like how you can just do that. But if you feel stuck, do not worry at all. Just refer to any resource. There are so many blogs, there are so many videos, there are so many things. You can literally use, because Docker is so popular, and it's, I think, yes, it is a complex thing to install Docker, but it is easily available how to debug, how to troubleshoot. And yes, you can also leverage ChatGPT or any LLM, okay, to identify like what's the problem, because every machine is unique. Even I know everyone is using Windows, Mac or Linux, but everyone's system variables, some system settings are different, Windows version are different, some are using Windows 10, 11, Pro, Home. So there are so many things. Okay, so yes, you have a small homework to do before continuing with this video. You need to install Docker and you need to make sure everything is running fine. But the good thing is I am also telling you how to install Docker. Okay, and I'm assuming that everyone is using Windows 11 or Windows 10. I think it will work fine with Windows 10 as well, and I think it will work fine with Mac as well, so it's not a big deal. But yes, feel free to use other resources as well, and do not be like a crybaby. How will I just install Docker? Bro, you're a data engineer, okay? I was just saying Docker engineer. You are a data engineer. You are an AI data engineer. You need to know everything like this. Just try it, just explore, just make mistakes and learn, and that's it. That's life. Okay, good. So let's try to focus on Docker installation one by one. Make sense? So I have created a cool mind map so that you will not be confused how to do the things. Make sense? Okay, let me just show you that. So first of all, let me drag the screen. Okay, so first of all, we need to install Docker. And if you do not know, in order to work with Docker, we should have WSL integration as well. What are these things? Do not need to worry. Okay, before even starting anything, you need to, first of all, so let's discuss the installation steps. So I have created this mind map, and again I'm repeating, I will provide the text version, detailed text version of this particular mind map so that you can just follow along. I don't think so you will face any problems, but you should be ready for everything, right? You should be ready for everything. But yes, I think this mind map will be enough to do all the things, but you should have that guide as well that you can just use, and you have so many blogs and videos as well to just install Docker. But still, I'm just covering that section in this particular video because I feel so possessive about you. Yeah. Okay, so let me just expand this particular mind map, and there are two areas basically, and we want to focus on the first one, environment setup steps, because this is the troubleshooting. If you install Docker and if you just run it, let's say after a month, it will not work. So it is just like a quick tip that I will just give it at the end of this particular section, but you do not need to worry about that for now. If I expand this, there are basically 5 steps involved. Step number 1 is prerequisites. Okay, so if I expand prerequisites, there are 2 prerequisites. Okay, and what are those 2 prerequisites? First is virtualization enabled. Okay, so how you can just check or enable virtualization if it is not enabled? In most of the scenarios, if you are using Windows 11 or I think Windows 10, it will be auto enabled, but you can still confirm it. So you just need to go to the task manager. Okay, just go to the search bar of your machine, just search task manager, and you should see the tab called performance on the left hand side. If I just show you, so if I search, let's say task manager, so it will be like this. And if you just go to performance, this is performance or this is performance? This is performance. Yeah. So if you just go to performance, you will scroll down and you will see virtualization. See here. See, virtualization. So just make sure it is enabled. Make sense? Okay, good. So if you just check if it is enabled, very good. So second thing, now you need to enable some Windows features. Okay, once the virtualization is enabled, you now need to enable some Windows features. Okay, what are the, bro, what do you want? What do you want? Let me just wear it. Okay, so now it was just like coming in my way. So now you need to enable Windows features. It is very important. Okay, what Windows features you need to enable? There are basically 2 to 3 Windows features. The first is WSL, Windows Subsystem for Linux. Okay, just go to your search bar and just search turn Windows features on or off. If you just search turn Windows features on or off, if you click here, you will find a long list of features. Okay, and just search those things, and you need to find WSL. If you see WSL, it is here, Windows Subsystem for Linux. Make sure it is enabled. Second thing is virtual machine platform. Second thing is here, virtual machine platform. You need to enable these 2 things and just need to click OK. Okay, now just restart your computer, because it will take effect once you restart your computer. Restart it right now and pause the video, or you can just simply watch the video on your phone and you can just do the steps on your computer. Okay, restart done. Restart is important. Okay, restart is done. Very good. Now what will happen? You need, if you just turn on the system, it will ask you some things. Hey, do you want to install this? Do you want to do that? Whatever it is saying, just say yes. Just say yes. Do not ignore it. Just say yes. Okay, just say yes. Very good. Now the second step is you need to install Docker desktop. So you can just go to any browser and simply say Docker desktop. Okay, so this is Docker desktop you can say website that you can just see, and you can simply go to products and go to Docker desktop. So here you will see everything and just scroll down and you will see download Docker desktop. I have already downloaded it, so you can just download it using your Windows specifications, Linux, Apple, Mac. Okay, same thing. We do not know how to use Apple, so we simply make mistakes while calling it. And then you can simply say AMD for Windows. Okay, so you can just download Docker desktop. That's it. Makes sense? So what will happen? Once you download the Docker desktop, then you also need to make sure, let me just expand it so that I do not miss anything. Okay, perfect. So now you also need to create a Docker account. How you can just create a Docker account? Remember, you downloaded Docker desktop from this application. You can click on sign in and you can just sign in with any account. It will be very helpful because you won't need to push your Docker images to the DockerHub. So just make your account here. It will be handy. Okay, so I am imagining that you have downloaded Docker desktop, you have created Docker account. Very good. Now, obviously download and install Docker desktop. Now it will ask you to restart your computer again. Yes. So just restart your computer. Okay. And then once it is done, you need to click on, or basically start the Docker and log in. So if you just log in, like let's say start the Docker desktop, it will look like this. So this will look like this. Okay, and then you can just click here and you will see your login as well. So I have logged in with my account. You can also log in with your account and you should see it here. It will be very handy. Trust me, it is not actually required, but it is recommended to just log in. Okay, makes sense. Very good. So this is also done. So congratulations, your Docker desktop is done. Now you'll say, wow, that's it. Yes, kind of that's it. But now I just need to, I think that's enough for this particular video. Okay. Like this installation is enough. You can just now work fine with Docker desktop. But now I'm going to just tell you some more extra steps that you can just do for your future development. I know you are a data engineer. You would be using Airflow. You would be using so many other applications. So I do not want you to feel like, hey, what if like Ansh could have just mentioned this thing in the video? It would be very helpful. So I want to discuss that step as well. So once everything is done, you can use Docker. It's fine. But now the steps are for future developments. Okay, let's say in the upcoming video, I'm just using Airflow. I'm using any technology which uses Docker. So you do not need to worry about that thing. I can simply direct you to this particular installation step and you can just follow along. Make sense? So that's why I'm covering this step, like all these steps here as well. Okay, everything at one place. Perfect. So now we need to make sure about the setting up the WSL2 integration. What is that? So basically, after installing Docker and restarting your computer, it will prompt you to install WSL2. I told you already, right? I told you. So just hit enter. If it doesn't prompt you or you didn't say yes, because I know you are very, very cautious, we don't want to install anything. And I know you have so much of stuff in your computer, which is like nonsense. So now, if it doesn't prompt you or somehow you miss the prompt, you can manually install WSL2. It's not a big deal. And the command that I will just tell you will be used to install the WSL. So what you can do, simply go to the, like obviously this step, I am assuming that you have missed it. Okay. But you now need to install it manually. So what you can do, you can simply install WSL using this command, WSL -- install. You can just go to your command prompt, PowerShell, bash, whatever. It will install WSL for you. Make sense? Okay, very good. Then you can just verify the status as well, like if it is there or not. Okay. So if you just hit or basically run this command, WSL -- list, then space, then -v, it will show you all the running instances of the WSL if it is there. And I think if you run this command for now, you will just see Docker desktop running. Okay, you will see Docker desktop running. If you do not see it, restart your computer and then again use this command, WSL list v. Make sense? Okay, very good. You should see only one thing, Docker desktop running too. You can see two things as well, but it's fine. If you are just seeing one thing, it's fine. If you are seeing two things, it's like amazing. You are so good. Okay. Now, after this, now you need to use WSL2 based engine in the Docker. By default, it will be automatically picked, but we need to make sure like we are using it. So what you can do, you can just go to Docker desktop and go to settings and then resources. I can just show you, go to Docker. Okay. And then go to settings or basically Docker engine, and not Docker engine, I think resources. Yeah, you will see this message. You are using WSL2. Make sure it is there. It is important. Okay, good. It is also done and you have confirmed it. Very good. Now you need to install Linux distribution as well, because in order to work efficiently with Docker, you need Linux on your machine because it works on Linux under the hood. Everything. Yeah, Docker works on Linux. Okay. So how you can just install Linux? You can simply go to your command prompt, your PowerShell, your bash, whatever, and you need to write this command, WSL -- install, then space, then -d, and then then Ubuntu. Okay. This will install the Linux distribution on your computer basically. And it will also ask you to just put the Unix username and password. You can just put any username and password. Okay. By default, I think it will pick your computer's username. Okay. And you can just pick any password. It is not like very, very important to remember, but yeah, if you can just keep a note of the password, it's good. Okay. Now you can just check the final verification. Okay. For Docker and Ubuntu. So now you can just go to favorite CMD. Oops. What did I search? Okay. So if I just go to my CMD, I should see CMD. If I write WSL -- list and then -v, I should see two things, Ubuntu running, Docker desktop running. Perfect. We need both the things. Make sense? So that's all about your Docker desktop installation. I know it is like not very, very complex, but for some outliers, it will be like very, very difficult. So you need to just make sure that it is running fine. Now, what is this thing troubleshooting? So sometimes when you run Docker desktop, okay, and you do not close it, you do not end it nicely, you cannot rerun it again. So it is like a very common problem. If you just go to Google or any browser, you will see this problem. Like a lot of developers are facing this problem. So it's fine. It's not a big deal. So what you need to do, the simplest thing is, it's most probably running in the background. So just go to task manager and kill the running instance of any Docker if you are running, okay, already. So if I just expand it, you will see it. Other Docker processing running, okay, just go to task manager and end it. And these are some tips. Using existing tips, you know what? Click Docker icon in your system tray, avoid needing to end process. So what happens basically, if you open your system tray, now you will say, what is system tray? Okay. I also didn't know. That's why I'm laughing. Okay. I laugh on myself. I love it. Okay. So now what happens if you just go to your bottom right corner and you will see that particular arrow like this, like this. if you click on this button, you will get the tray and you will see the Docker icon there. It will be only there if any other instance is running. So let's say I open Docker. So let's say this is the Docker, right? This is Docker. Do you know what? If I close this and now if I try to reopen it, I cannot. It will not open it. So if I simply say Docker, what is this? Let me just search it here. Okay, Docker desktop. So now I have hit the command using my different screen. Okay, so it will not open it. I'm so sure. Why? Because it is already running in my tray. So in my tray, now I will see the Docker icon and now I can click on it. So yeah, it was just a quick tip. Okay, so I hope now everything is fine, everything is sorted, and now you know how to install Docker easily. Makes sense? Very, very, very well done. And this is actually a pain point. And if you installed it easily, then say thanks in the comment section, because I created that mind map just for you. I put all the instructions, all the text messages to convert that text into, you can say, mind map, okay, using modern technologies, LLMs. So yeah, I hope it is helpful. And I will also upload the text version of this installation guide in the GitHub repo. Okay, makes sense? Very good. So now let's do the real development. Let's get started with the real development. Okay, let's do it. So first of all, you can open any code editor. If you have VS Code, perfect. If you have PyCharm, good. If you have Cursor, good. You can open any code editor, and even like it will work without a code editor as well. But if we are just using code editor, it makes life easy, because you can see the code, you can just do a lot of things, you can open terminal together and do not need to go here and there again and again. Okay, so just open any code editor, and I would expect you would have VS Code editor in your system. If you do not have, simply download it on your machine using Google Chrome or anything. Okay, so let's get started. I assume that you have VS Code editor installed on your machine, and if not, bro, are you a data engineer? Okay, so now what are you gonna do? You can simply go to file and go to open folder. Okay, and just create a new folder, or you can just open an existing folder. I created a new folder called Docker tutorial. You can also create a similar folder just to make sure like everything is running fine. You can even create the Docker container with the same name, so that it will help you to just use the same commands that I will be using. So you do not need to worry at all about commands and all. Okay, so you can simply copy and paste the stuff. Okay, makes sense. So now what we need to do? We need to create a simple project. Okay, we need to do a simple project, and obviously we are learning Docker, so we are not prioritizing the code that we are writing within that. We are not writing ETL pipelines. We will write ETL pipelines as well. Don't need to worry. Okay, simple ETL pipelines, but you do not need to focus on the code, because in your application you can literally write 1,000 lines of code or maybe 1-2 lines of code. The intent is to learn Docker. Okay, so do not feel like, hey, why are we just developing this simple application? We do complex things. See, here's the difference. You are learning Docker, and Docker doesn't need to worry about anything that you are writing in your application. Even if you're writing 1 line of code, or if you're writing 100 lines of 1,000 lines of code, it doesn't need to worry at all. So it's up to you, like what you're trying to do. Okay, makes sense. So I just wanted to make it clear, because some people are like very 1% of people are there like, what are you doing, bro? Building simple application, bro. We are not learning Flask. We are not learning here Python. We are not learning ETL with Python. We are learning Docker. We need to learn Docker. Okay, so now let's create a folder within this Docker tutorial, and I will name it as, let's say, projects. Okay, and I am using some extensions that you can also use for these icons. Simply go to this extension. Okay, if you click here, you will just find, I think it's called material something. Yeah, material icons theme. So you can also download it if you want. And there's, I think, one more theme that I was using, but I don't know. You can just use any theme. There are like so many themes available for icons and all. So you can just pick this one if you want, and it will allow you to see these icons, and these look cool. So it's fine. So I have this folder called projects, and I will open this folder and I will create one more folder within this. Okay, or even before that, let's try to do something. Let's try to, like, we do not need actually Git, because we are not doing the deployment, or we are not creating a repository. So it's fine. It's fine. To be honest, it's fine. So what we need to do, we will simply go to the individual projects folder. Okay, or even without that, I think it should run fine. We can simply say project 1, project 2, project 3, but it will look cool. Like we have projects and within that we have all the things ready. Okay, makes sense. So now what we need to do, we can use something called as pip or UV both. What did I say? Pip and UV both. Pip is the Python package manager for us, and we are using pip since so long, but now we have UV as well. So you can literally use pip or UV both, and it is compatible with both the things. So what you can do, simply go to your terminal, open your terminal. Okay, and you can say pip install UV, because I personally love UV. You can also use UV. Simply say pip install UV and it will install UV on your system if it doesn't have that. Okay, so it will say, for me, it will say requirement already satisfied because I already have UV installed on my system. In your case, it will simply add that thing. Make sense? So once you have UV installed, you can start using UV. Just to clear, it is not a kind of big thing. Even if you use pip, it's fine. But I want to just make you aware of these things as well as we go along with this video. Okay, so what I'm going to do, I will simply create another project within this, and I will go inside this and I will simply say 1, because this is like chapter 1 kind of thing, and I will simply say first app. Okay, first app. So I'm inside this folder and I will simply create another file. It's called app.py. You will say, Ansh, Lamba, you didn't install Python. I do not need Python, bro. I do not need to install Python because I have Docker. I will use Docker's engine to run my Python. Wow. Yes. That's the power of Docker. I do not even need to install Python in terms of running Python. Amazing, right? Very good. So now within this app.py, what I'm going to do, and even before that, I can do one more thing. I can simply go within this folder called first app. So I will simply say cd and then one first app. Okay. It is saying because it does not exist. Wow. Really? Oh, because we have projects and then we have that thing. No worry, bro. Okay. So now I can simply say UV init. Now what is this command UV init? I love this command. It will automatically create a virtual environment for me. It will create everything for me. I know I do not need these things, but I'm simply telling you how you can just set up the project. If I hit UV init, you will see everything is created for me within this first app folder. Git ignore, Python version, app.py that I just created. It will create main.py, pyproject.toml, readme.md, whatever. For now, we do not need these things. But in the, you can say, advanced projects that we're going to build in this particular video, you should be aware of these things because it makes development smoother. And these are some kind of best practices. Okay. But for now, I'm simply deleting all these. Okay. So I can simply say delete all these, but you should know how to create those things. Okay. Perfect. Nothing is there. Perfect. Let me just delete this terminal and let's open a new one. So in this particular our folder structure, we just have app.py. That's it. So now within this particular app.py, I will write my code. I will write my Python code that I want to develop. And what kind of code that I will write? Very simple code. I will simply say print, hey bro, this app will run in the container. Let's say, okay. So this is the application. Let me just save it. So I want to run this application. This is my application. I want to run this. Make sense? I want to run this application. Okay. So I will run this application. Okay. So what I will do now, I will take this code and I will containerize it. You know the steps. If not, do not worry. I will just tell you step by step. So first of all, I will create what? Dockerfile. Okay. Dockerfile. I will create another file and at the same level, see where I have app.py, I will simply say Dockerfile. Okay. And where it has created Dockerfile? Within this? No, I think it needs to create under this. Perfect. Okay. So we have Dockerfile. So this is the Dockerfile, and we all know, we are not discussing the fundamentals again. Dockerfile is used to build the image. Make sense? So how we can just build the Dockerfile? It's very, very simple. We first need to pull the base image. Remember, everyone, we discussed right here. Remember, we first pull the base image, right? And then we just copy the code, install all the libraries and blah, 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 blah. Okay. Okay. Perfect. So we need to just do this thing. Okay. So I will add a comment because I need to upload all of these to my GitHub repo so that you can also use it. So I'll simply say pull base image for Python. Okay. What is the code for it? It's very simple. You will simply write from and then the image name. For now, I'm using Python 3.8 Slim. This is the base image name. Ansh Lamba, how do you know this? Very good question. Let me just tell you how do I know this. So in order to find the base images for anything, you need to go to any, let's say, browser, first of all, and you need to search for, let's say, DockerHub. So we have a DockerHub and just go to that website and here you will find everything. So let's say I want to use base image for Python. So I will simply search Python and hit enter. And here you will see so many options. So you need to simply click on the official images, Python official images. Click here and you will land on this particular page. Okay. Now if you just scroll down, you will see there are so many images available. 3 Alpine, 3.21, Bookworm, Slim, Trixie. There are so many images available. See, so many images available. You can pull any image. Why did I pull Slim image? Because Slim images are like lightweight images and you can do a lot of stuff with that. Okay. I like 3.8 and 3.9 both. And Slim images because they are lightweight. And I do not go with the latest version because it can contain some bugs. Okay. So I just go with the previous versions like 3.8, 3.9, 3.10, 3.11 is also fine. But just for this particular tutorial, we are using 3.8. Okay. And you can just use that as well. Makes sense. It depends like what you are developing in the code. If you're developing something new features or let's say using new features of Python, obviously you need a latest version of Python image. But for the simplicity, we are just using 3.8. And if you just want to see the tags, you can just go here tags and you will find so many tags here. See 3.11, 0.14, 3.11. So what you need to do, you need to simply say Python. See, there's a command here. For every image, there's a command. Docker pull Python, Docker pull Python. See, Docker pull, Docker pull, Docker pull, Docker pull, Docker pull, and so many pulls. Why, Ansh Lamba, you are not using this command like Docker pull and you are using the code directly here like from? If you create image using Dockerfile, you need to put the code here in the same syntax that Dockerfile accepts. But if you directly pull the image, remember there are two types of images. Remember? If you need to use base image directly, then you use Docker pull and that's it. That is why I have used just pull base image. Makes sense? That's why I explained all these fundamentals in detail. See, these are the building blocks of your learning journey. It depends upon you, like what's your attitude towards learning. Okay. So now we know that we want to use Python. Okay. And here is the code. If I copy it like this, I can go here and I can paste it here. And I do not need to use Docker pull. Very good. I can remove it. And this is a tag. So now it's my choice which tag I want to use. Okay. So I will use 3.8 Slim. Makes sense? And you can also search it. If you just go on the filter bar, you will say, let's say 3.8. Okay. And hit enter and you will find some 3.8 tags. 3.13, scroll down, you will find it. See 3.8, bullseye, 3.8, slim, 3.8.20. You can use anyone. See 3.8 without slim, but it is so big in size, 300 meg. Okay. And if I use 3.8 slim, I get 46 MB. That's it. Ansh Lamba, why didn't you put 20 as well? It's fine. You can simply put 3.8 and it will work fine. Because it will pull any image of 3.8 slim version, no matter like it's 2.0, like 2.0 or whatever. So we have 3.8 slim exact as well. So I'm using this one. Makes sense? So whatever image you want to use, base image, you can simply go to DockerHub and get the image. Simple. Okay. And we will be using so many other images as well. So cool stuff. Okay. So now we have pulled this image, but obviously this is just an interpreter, right? Now we need to share our code in this particular image. Makes sense? Because see, this is just a Python interpreter, Python engine, that's it. If we want to run our application, we want to copy the code as well, right? So what I will do, I will simply create a working directory. So whenever we create an image, we set the working directory, we create a working directory in the image itself. So I will simply say working directory is app. What it did, it will create this folder called app. If it is already there, it will set it. If it is not there, it will create it. So this app folder is registered for my image. Oh, okay. So now whatever I will do, copy, whatever will be done inside this app folder. That's it. So I have set the working directory app in the container or in the image, basically, not directly in the container, because container is just the running instance of the image. Okay. So you can say set working directory in the image. Like it's when I was also learning this thing, I was also confused, like, will it create the working directory in the container or image? Originally it will create it in the image, but yes, container will replicate it because container needs to run it as well. But ideally, logically, it will create the set working directory in the image. Makes sense? And you will see it. You will see all the steps. When I will just creating this image, you will see all the steps listed. Perfect. Very good. So we have created one folder called app directory, and now we want to put everything within this particular folder, our code, whatever we have. Okay. So I will simply say copy the current directory contents in the container at app. Copy the current directory contents. I will simply say add the app. Perfect. So I'll simply say copy dot app. What did I write? Just look at it. I said copy dot. What is dot? Dot is the current working directory. And what is the current working directory? This one. First app. And what do I have within this? App.py and Dockerfile. So it will copy both the things in the app folder. Both the things. App.py and Dockerfile both in the app folder. Okay. I can also do this thing. Let's say copy app.py into the app. So basically this is a source. Okay. And this is the destination. Source on your machine and destination on the container side. Make sense? Very good. I can also do this thing. And then I can also say copy another command if I want to copy Dockerfile. Okay, in the app. So I can do this thing, but it takes a lot of time if you just want to do everything one by one. So I will simply say copy dot and app. Make sense? Make sense? Copy dot app. Perfect. Make sense? Okay, very good. Copy dot and app. Now you will say, Ansh, Lamba, do we need Dockerfile inside the container? Obviously no. Okay. Why do you need Dockerfile inside the container? No, you just need the code. You need Dockerfile just to build the image. Once the image is built, you simply run the image itself. You do not actually need Dockerfile within the container. So you can ignore it as well. But just for the simplicity for now, I am simply putting it as well. There's no harm, right? There is no harm. Okay. You should put extra stuff, but do not leave any stuff. Okay. So our code is also there. Okay. Do we have any kind of dependencies? For now, no. We do not have any kind of dependencies. So I'll simply say we do not have any dependencies. Just run our application. So let's run the application. So I will simply write this. Now this command is very, very important. This command is very important. What did I write? Run the application. Do you know what? This CMD command means your command that it will run, only run when the container is initiated. What does it mean? So everything before running the application will be done on the image side. Okay, everything. We are pulling the slim image, we are creating working directory, we are copying our code. Everything is being done in the image. Once the image is built, then when we will turn on the container with that image, we will run this command, which is called Python app.py. Now, Ansh, why we are doing this thing? Because if we run our code normally, we simply write this Python app.py, right? This is a normal command that we use to run our application. But why we are just passing a list and comma and blah blah? So in the Dockerfile, if you want to say, hey Docker, please run my application with this command, it needs each word, each keyword separated by comma within the list. So this list is actually equivalent to this one, Python app.py, and that is, we have just separated it. That's it. Oh, that's it. Yes, that's it. Wow, this was cool. So this is our Docker file. Let me just save it. And that's it. This is your application. Now you want to run this. You want to see this, right? So let me just show you. So first step is you need to build this image, basically build the image from this Docker file. Okay. How you can just do that? Open your terminal. Okay. And you need to navigate to the directory where you have this Docker file. So I'm already inside this Docker tutorial and I have this file within projects, and then after projects I have one first app, right? So I'll simply say cd projects, and then I have one first app. Okay, now I am inside this folder. These are some, you can say, command line commands, command line interface commands, CLI commands that you should know. And these are like PowerShell commands. You can also see like if we have anything else, because PowerShell is compatible with everything, Linux, Mac and Windows. So best thing is PowerShell. But if you are just using Linux, you can just use Linux commands as well. I am not a big fan of Linux commands for now, till now. Okay. So yeah, cd, and I'm inside this folder. So now I will simply say, now this command is important. Docker build. Now what this command will do? Docker build. This command will, see everyone, Docker build, it will build my container. No, it will build my image only. Whatever we are doing for now, we are simply building the image, not the container. Make sense? So Docker build, and then you just need to pass the image name. Obviously we will just talk about it as well, but you need to first of all understand like how you can just do that. Okay, so this command is very, very important. Docker build, and that's it. Docker build doesn't mean Docker container build. Do not be confused, because it is confusing, but you do not need to worry about that. Docker build means we are building the image only. Okay, now I want to just provide a name, basically tag to my image. I will simply say T, and I will say first Python app. Simple. Let me hit enter. You will see Docker buildx. What? Oh, obviously. Okay, I'm glad that this error came. So basically it is saying, hey, Docker buildx build requires one argument. What is that argument? Location, where the Docker file exists. Our Docker file is here, dot, is at the dot. That means in the current working directory, because we are inside the one first app. So I will simply pass the location as well where my Docker file is. Now hit enter. So now what it is doing, just look at the logs. See, so it has built my Docker image. See, all the steps are here. It is running my first step from this image. It has pulled this image. Okay, then it created this application folder. Then it copied my application code into the app folder, and that's it. So everything you have done here, I told you, is done inside the image, not inside the container. Container is out of the picture. So far it is not included, and that is why you are not even seeing that cmd command, because cmd command is a part of the container, not the image. Make sense? So whatever you have written here, so yeah, I was saying that whatever you have written here is not the part of container, is the part of image itself. That's why I corrected this thing as well, because it is a common mistake. Yes, even experienced ones will tell you that you are creating app container within the, like you are creating the app folder in the container. No, you are creating the app folder in the image. Okay, very good. So now our image is ready. You will say, Ansh, Lamba, where is the image? Can we see it? Yes, just go to Docker. Okay, this is my Docker. And if you just go to images, you will see this particular image. See, first Python app. Wow, this is my image. Okay, if I click here, and what is this tag? What is this tag? So if you do not provide any tag while building the image, it will get the tag called latest. I can even create another image of different tag. Let's say I want to give the version. So I will simply say, let me just clear out the stuff. So I'll simply say Docker build first app, and I can just pass the version, let's say tag, or not like this. I can simply say 0.1, let's say. So if I hit enter, what it will do, it will create another image for me, and it will see, now this time you will see tag as 0.1. This is very handy when you need to just tell about the tag. Hey, I want a tag of 0.1. I want a tag of, let's say, latest. If you do not put any tag, it will be latest. But if you just want to specifically mention the tag that this image is of 0.1 version, 0.2, whatever, you can do that. It's your choice if you just want to do it. Okay, so I can just delete it because I just want to put the latest tag. Okay, very good. Now, this image is built. Now we want to run the container, right? Now we want to run the container. Now how we can just run the container? It's very easy. Okay, because now we want to run the container. And if I just open this, you will see that all the things are here. See, CMD, environment path variables, everything is there. And these are called layers. Okay, because there are so many layers in our image. Okay, and it is saying everything it created 4 minutes ago. This is the size, 188 megabytes and all. Very good. Now we want to run this image. In order to run this image, just go to your terminal once again. Okay, so now you can just write this Docker run. When you write Docker run, you are saying that we want to run a container. When you say Docker build, you are saying that you want to build the image. Difference. Okay, Docker run. Very good. Now you say Docker run, you can simply provide the name as well to this Docker container. If you do not provide the name, it will take a random name. Okay, I'm not a big fan of taking the random name because it is very confusing when you have so many containers. So I will simply say name. It's a good practice. So I will simply say first, what was the name of image? Because I always keep the naming convention same. It is saying first Python app. So I will simply say first Python container. Make sense? Okay. So I want to run this container. Makes sense. Now I want to tell, okay, run this container, but what image I need to run within this container? I want to run the image called first Python app. Makes sense? Simple command, simple everything. Okay. Okay. So now if I hit enter, it will run the application. Where is the application? See, hey bro, this app will run in the container. This is running in the container. Did I use Python? Like, did I mention like you need to install Python? You will say, hey, you already have Python in your system, bro. Trust me, this is running in the container. Let me just show you. Let me just go to the Docker. Okay. And if you just go to containers, you will see this container. Wow. If you click here, you will see everything. See logs. So this is actually running in the container. Wow. This is amazing. Yes. Yes, yes, yes. But why it is turned off? Why? If you see, it is not green because your application ran, it printed that statement that it is running inside the container and it stopped because it was not running at all because it's just a print statement. That's why it stopped after running it. Wow. Okay. I will show you one more thing. Let's delete this container. You can also run the interactive containers if you just want to see the content within the containers. For example, I will run Docker run and I will add one flag called IT. IT means interactive shell, and I will pass the location as well. Let's say I want to run bin and then shell. If I hit enter, it will run the container. Container is running and I will get the interactive shell as well. If I say ls, just to see what I have inside this container, I will see Dockerfile and app.py. Wow. What is this? This is the exact stuff that I have. Ooh, but why it is inside the container? Because we added everything in the image. Okay. And what is image? Image is that what we built. And what is container? Container is just running that image. So for example, see, let's say this is your code. Let's say this is your code. This is your host machine. Okay. This is your host machine. Makes sense? Okay. So here you have the Flask code, whatever. Okay. Here you have, let's say, code, whatever you have written. Okay. Here you have everything. Okay. Perfect. So this host, okay. This host will be copied into image. Make sense? Very good. Into image. Yes. Same thing. This will be converted into image. Perfect. Now this image will be running inside the container, as we know that. Okay. So this will be running in a container, right? So that is why whatever things you have here will be exposed in the container as well, because container is running that application, that particular image. Makes sense? Makes sense? And if you just want to go a little bit deeper, so what happens, whatever you develop as the image, whatever you, let's say, put in the image, it creates a read only. This is like extra stuff you can ignore if you want, but if you just listen to it, you will get some more understanding. Okay. So it is a kind of read only layer. Okay. Read only layer in your image. Whatever you have done, like copy the code, app.py, everything is like read only. Okay. So this is read only layer where container doesn't have any power to change it, because it has just a read only access. But what it does, it reads that data. Okay. It will, let's say this is read only. So it will read this data and it will create a kind of replica of this. It's called write only or read write both. Writable layer. In short, it is a writable layer. So this will create this kind of layer. Make sense? Make sense? So this is a kind of writable layer. This is the read-only layer of the image, whatever we have, whatever code we have here. And this particular thing will have a writable layer. Let me just encapsulate this inside this. I think it will be easier to understand. Okay. Perfect. So I hope you are getting my point. I hope. So this is a read-only layer. Okay. So this read-only layer will be created inside this particular thing called writable layer. Perfect. Make sense? I hope it makes sense. So this is a kind of writable layer. So what happens when it creates a writable layer? What's so magical within that? See, there's nothing magical, but what will happen? This readable layer will have a writable layer. So it cannot change anything. It cannot change anything, but it can use that stuff, right? It can use that stuff and it can use that stuff to replicate the same thing. So if I just go to my Docker, what is trying to do? This container is running my application. Okay. If I go to containers and you can see it is running fine. If I open this, it will still be running. Why? Because I have opened the interactive shell. So it will not stop until unless I stop it. If I go to execute, or I think if I go to files, yeah, just go to files. You will see all these folders. See all these folders. We do not worry about all the folders, but we worry about this app folder, because this app folder is created through the Dockerfile. If you open this, you will see both the files, app.py and Docker. Same stuff. So what it has done, it took the readable layer of the image and it replicated the same stuff. What did you say? Replicated. it replicated the same stuff into the container and it added the same folder here. Why? Because now we can make some changes. Let's say I want to create one more file in the app.py. I can do that because I have the liberty. I have the writable layer now, but Docker cannot do the changes in the image. What is the benefit of it? It promotes isolation and security, because if you will allow your container to make the changes directly in the image, okay, and let's say this image is now being used in the prod environment and you are making changes in the QA environment, it will break everything. It will break everything. Point. Because you just need to use the image, right? If you want to make anything like, let's say, on the spot changes, you need to do it in the container. That's why we create a writable layer. Make sense? Make sense? Make sense? Make sense? I hope it makes sense. So that's how you can see everything. Nothing is hidden from you. You just need to use write commands to see the content. See, everything is there in front of you. App.py, Dockerfile, everything. And you can even run the commands here as well. If you just go to execute, if you say ls, you will see both the things. If you say cd ... you will go one step back. You will then say ls, you will see all the folders, app, bin, boot, dev. All these folders are created by a container. We do not need to worry about this, but this app container is created by our Dockerfile. If I now go to cd app, if I go to ls, I will see Dockerfile and app.py. Wow. Wow. So basically this thing is created inside the image, but this thing was replicated in the writable layer. Makes sense? This is like a little bit technical. If you do not understand everything, it's fine. It's just like the extra knowledge that I'm just providing. Okay. But obviously if it is like being provided, just take that knowledge. It will be helpful to you. Make sense? Okay. Got it? Everything sorted? Understood the concept? Like what we are doing here? Very, very, very good. Okay. So now if you just want to turn off your container, how you can just do it, or you can say stop the container. You have both the options. You can either click on this button, which is called stop. And if you just want to know the command for it, because it will be keep on running because you have opened the interactive shell. So it will not stop until unless you say that, hey, stop. So basically I will tell you both the ways. You can click here, it will be stopped. And I just want you to learn the commands as well. So if you just go here in the command shell, and let me just open a PowerShell or a new terminal basically. So if I say Docker stop, okay, first of all, if I want to see how many containers, Docker desktop is a cool thing. Okay, we can see everything there, but let's say we want to check what containers are running now. Okay, so I can simply say Docker PS and I will get this Docker container ID, Docker image. Command is bin shell because we opened the interactive shell, and it will just show us all the containers running for now. If we want to see all the containers regardless of them running or not, so we can simply say Docker PS A. It will show you the list of stopped containers as well, and perfect. Now let's say I want to stop the container because I know this is running for now. Okay, so I can simply say Docker and then stop, and then I can either provide the container name or container ID. I personally prefer passing the container ID. It is a better option. So I will say container ID, copy and paste and hit enter. It will stop the container for me. So it is now stopped. If I open the Docker desktop, I will see nothing is there. See, it is not running now. Okay, it is turned off. Let's say I want to remove this. You already know you can hit this button. You can do that. But if you just want to know the command, you can say Docker remove RM and then container ID. Hit enter and it will remove the container. If I open the Docker, now I have 0 containers. Will it also remove the image? No. No, I have still the image ready. Why? Because same image can be used by so many containers, right? Because see, image is just like a recipe. You can use it to prepare multiple meals. Same recipe, let's say you want to eat Maggie. Maggie. Yeah, let me just tell you one thing. So see, Maggie is very popular in India, okay? But no one knows Maggie outside India. Like the real name is noodles, but we never called it noodles. So when I came here in Canada, so there was a Nigerian guy. He was like, what do you want to eat? I was like, I will cook Maggie. He's like, what is Maggie? I was like, you don't even know Maggie? And he was holding a pack of noodles with obviously different brands. So I was like, this is Maggie. He was like, it is not Maggie, it is noodles. I was like, yeah, same stuff. We just called it as like Maggie. So let's say you want to eat Maggie. Okay, noodles. Ansh, say noodles. Let's say you want to eat noodles and you have a recipe in mind that you will cut vegetables, you will add mushrooms or whatever you want to eat. You have that recipe set. You can use that recipe, you can cook your meal, you can pass that recipe to your friend. Person can read the, not read, like cook the meal, okay, make Maggie, noodles. So same thing here. You have the recipe ready. Now any container can use it to run the basically image, right? So that is why we do not need to remove the image. But yes, you can remove if you want to. If let's say I want to remove this image, I can simply say Docker remove image, RMI, and then I can pass the image name or image ID. I do not know the image ID. Okay, so I can simply say first and then Python app. There's a command to list all the images as well. If I am not wrong, I can just simply search because there's no need to remember all the commands. Okay, so list all the images in Docker. So yeah, Docker image ls. So I can also say Docker image ls, but right now we do not have anything because I have removed it. So if I say Docker image ls, I will find nothing. Okay. Make sense? Okay, this was cool. This was like a very basic application. Now we do not have anything. See, our image is empty, containers empty. Perfect. Now let's try to build our second project. Okay, it will be a kind of real-time application where we can just do a lot of stuff instead of just printing the code. Okay, we will just develop a Flask API because being a data engineer, you need to build APIs, right? Yes, nowadays, yes. Earlier, obviously, no, because they were like totally dedicated backend developers, but right now data engineers are supposed to build the APIs because AI data engineering domain is here. So yeah, so AI engineering means you need to know software engineering as well. There was an era when software engineering and data engineering used to go in parallel. But now I can see the blend happening. So now software engineering is blended with data engineering, and that line of blend is called AI data engineering. Let me just show you. So let's say there was a domain called software engineering. Okay. Software engineering. And there was a domain, like isolated domain called data engineering. Data engineering. This gap was big. Initially, but this gap started collapsing. This gap used to be like go here, and now finally we are in the era where it has overlapped a little bit. See, not entirely. I'm not saying like we do not need software engineers or we do not need data engineers. We need both, but now this area is like now blended. And this line is called, do we have red color? Okay. This line is called AI data engineering. Or I can say vice versa. AI data engineering created this line, or this line created AI data engineering. Both are true. Okay, so this line is AI data engineering, where you need to know data engineering and software engineering. That means you need to know how to build APIs, how to automate stuff. Automate is like data engineering, but I can say how to, let's say, route the data from one endpoint to other endpoint, how you can just create APIs first of all. Okay, basis of everything. Then some front end as well. Front end is like more on this side. See, this is AI data engineering, but obviously, let's say if you want to build a kind of dimensional data models, that area will be pure data engineering. If you want to, let's say, build front end, React, Next.js things, that area is still here. That area is still software engineering. But let's say you need to build ETLs, automation, work with data, RAG databases, and at the same time you want to build the APIs, then you have to be the AI data engineering. And this is a domain which is booming. Okay, I can just put this as well if you want. as nodes. Okay, this is a domain which is booming. So that is why I do not feel like we do not need to learn front end. We do not need to learn, like, front end is like the last thing that you can just learn, because front end can be easily done by AI, and you just need to be smart and just need to be proficient in the prompts. You can build the front end, I'm so sure. Okay, and being a data engineer, okay, I'm not saying like software engineers do not need to do that, to do anything, but I'm just talking from the data engineering point of view. So you need to learn APIs as well. You need to learn so many things, and that's why you will see some lectures very soon if you want. Okay, we can just obviously focus on those areas as well, because that is very important. Now data engineering is not that data engineering that used to be like, okay, building dimensional data model, okay, building this, that is still there, but you need to learn so many other things as well. You need to upgrade your tech stack. You need to upgrade your skills. Yes, it is a matter of time. Yes, it requires efforts. Yes, it requires a lot of dedication. Yes, it requires a lot of consistency, but the one, or let's say the 1% will succeed in this domain, and that 1% gonna rule the industry, because nowadays companies do not need many employees. No. They just need the people from that 1% group who knows these things, and, or let's say who know all of these things, who can easily manage everything, who can just do, okay, data engineering, okay, software engineering, okay, automation, okay, AI, okay, this. So they need that talent now. They do not need to spend the amount in like on, let's say, 10 different people. So what's going to happen, let's say they used to hire, let's say 10 people. Let's say, I'm just giving you the reality checks. The rest is up to you if you just want to believe or not. Okay. So let's say they used to hire 10 people. Okay. They used to hire, let's say, this same individual like this. Let's say 1, 2, 3, 4, 5, 6, 7, 8. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's draw one more. 10. So what's gonna happen? Let's say they used to hire 10 people, and they used to spend, let's say, around let's say $1 million. Okay, $1 million. Let's say 100K per developer. Okay, $1 million. They used to spend this amount on these resources, basically. Because see, you are a developer in your eyes, but you are not a developer in leadership, or you can say in the eyes of leadership. You are just a resource to get the work done. You are not a developer. You are not a, you can say, even a human being. You are just a resource to just get the work done. This is a reality check. If you want to accept it, accept it. Otherwise, it's your life, whatever you want to do. So you are not a developer. You are not anything. You are just hired. You are just being paid to get the work done. That's it. You cannot say, hey, I'm a developer. See, I am learning. See, I'm doing this. No. They do not worry about these stuff. So what they're going to do, they are spending $1 million for now. Okay. For these 10 developers. Okay. Makes sense. Now they're going to hire just, let's say, 3. Okay. Just let's say 3. So all these people are gone. Okay. All these people are gone. Or let's say they're going to hire 2. And this is very true, bro. They're going to hire just 2. Okay. Now, you will say, what will happen to this amount? Obviously, they have the budget to spend, right? Obviously, they will not spend $1 million now. What they will spend? They will spend, let's say, $500,000. Okay. Cost cutting, supply and demand. Okay. They just want to see the numbers in green. They just want to see their dashboards in green. They just need to see their growth in green. That's it. They are just worrying about that thing. They are not worrying about, hey, do you have a family? Do you have like family members? You want to pay fees to your children? They do not worry at all, bro. They do not worry, and they will not worry at all in the future as well. You can worry. You are a family member of your family. They are not the family members of your family, right? So what they're going to do, they're going to cut the cost, $0.5 million. Now they can just show this number in their dashboards. Hey, we earned $0.5 million more in this year, in this month, in this quarter. Boom, big win. Now, these 2 developers gonna earn more. Why? Because they are doing the work for, let's say, 10 developers, and they are saving the 50% of the cost. So they will get now 250K each, or you can say 0.25 million each. Okay. So 0.25 million each. Make sense? 0.25 million. How much they were earning before? 100K, right? 100K. This was the salary before. Now what? How much they are earning? Almost 2.5 times. So these are the people who come into the 1% group. So they're gonna earn almost double, triple, and in some cases even 10 times but at the same time, all the 99% of the people gonna earn even less, or I would say maybe not be earning anymore in this domain. Is the reality. It's up to you if you want to upskill, if you want to focus on learning, or if you just want to be cool. Hey, we are learning in the job and we do not need to learn Docker. It's not like in our scope. It's not in our domain, bro. do whatever you want. Do whatever you want. Okay, so I just gave a clarity on, or you can say a reality check on the things that are going right now. And this was a specially talk for my lovely fam, because I do care about them a lot. I love them. And I know that 1% or 2% of people, they will say, what this person is saying, this is just wasting the time. Okay. So just a quick tip, and do not worry, bro. I'm with you. I will try my best. I will try my way best to just share all the knowledge that I can. Simple. And obviously on YouTube for free. So just make sure. And see, it's not about just sharing the knowledge for free. I just want to make data engineering, or you can say AI data engineering learning, accessible, affordable. Affordable is the word. And just mark my words, I will. But I need your support, obviously. I am no one to do anything, okay? I need your support, I need your blessings, I need your back. Okay, so just do let me know who are with me in the comment section right now. I will see and I will read the comments, and I will decide, okay, who are with me. Okay, so yeah, it was a cool talk, just a reality check. Okay, so let's focus on learning, because we want to be in that 1% group, right? Agree? Very good. So now let's try to build another project, and it will be like real world. We will just try to build an API, a simple API, not very fancy API. But with this particular API building, you will get the real-time knowledge, because there are so many things that you need to be aware of, such as port mapping, all of those things that you need to know in Docker. And I want to show you directly instead of just demonstrating those stuff. I have already demonstrated what was needed. Rest of the stuff we're gonna learn by doing it. Make sense? Okay. Very good. So what we're gonna do, we will simply build a simple Flask application, nothing fancy at all. And we're gonna just look at the things that we will just working with. Let's build another folder within this, and let's call it as, why it is creating folder within this? Okay. So we're gonna create, let's say, Flask app. Okay. So this time we'll be creating a Flask application. Perfect. So just open this folder and let's create a file called app.py. Okay. And let's try to write our code. So I will simply say from Flask, import Flask. Obviously it will give you this error that you do not have this module imported. See, because we have not imported anything, because we are not even using our systems machine, like systems Python interpreter. We simply need to do everything in the container. But do you know what? This is a very good sign that we need to install Flask in the container, right? While running it. Okay. So we need to tell Docker container that, hey, you need to install Flask. But how? For that, we always create a file called requirements.txt. Requirements.txt. Perfect. So here I can just put Flask. So what it will do, it will store the information that we want to install this Flask application. How? I will just tell you. So for now, we are simply creating Flask application, and let's create application equals to, and we are not mastering Flask for now in this lecture. Okay. So simply copy the code that I'm doing, and it's not a very, you can say, detailed knowledge that you need to get to understand this code. And let me just explain you. So first of all, you create an application. Okay. You can just name it as anything. Let's say app1, root, whatever. And then you can simply say name. After this, you need to create a route. So whenever you go to a website, you go to routes, right? So if I just show you any website, let's say this website. So see, these are the routes. So this is the base URL, like till.com. This is the domain name. But after that, you have this particular route called search. Then you went to this route. Make sense? So what I will do, I will create a route called, let's say, default route, which is the base URL. So I'll simply say @app.route. What is @? This is a decorator in Python. You need to learn Python if you do not know. And I have a dedicated video on Python, like Python Masterclass or Python full course. You can simply check, and it's an amazing course. So you can simply search Python full course Ansh Lamba. And just a quick tip, If you want to learn anything in the world of data engineering, or you can say AI data engineering, simply search for that topic and just add my name, Ansh Lamba. You will find the video for sure. See, Python in 6 hours for data engineers. This is a complete course from scratch where you will understand everything. Okay. And there's another video called Advanced Python that you can watch after this video. This is a kind of second part of it, or you can say advanced version of this video, where we just talk about AI modules in Python and what are those packages that we use in the AI engineering. Okay, good. Very good, very good, very good. And let's focus on our code, what we're building. So I'll simply say app.route. Now I need to use the same variable here because this is my application. Okay, and this is the route that I want to build, app.route / and then I will define the function. I will simply say def home. Okay, and what I will return, I will simply say hello, Flask app is running in Docker. Simple. Okay, let's create another route. I will say app.route about, and I will simply say this is a simple Flask application running inside a Docker. I will create another route. I will say contact. Let's say I want to create contact information. Contact us at contact us at, let's say this ABC. Okay, so this is my simple website or simple API that I have created. Not a website, because Flask is like, you can say, a framework that you can use for front end and back end both, but usually you will create the APIs for the back end. Okay, so now I want to run this, and I will simply say run name equals to machine, app.run host equals 0.0.0, that is local host, and then you will simply say port equals to 5000, because you need to expose this Flask application in a port. Okay, every application, everything that you run in a machine, it gets exposed to a port, and port for Flask application is 5000. Okay, and then I will simply say debug equals to true. If we have any logs, we can see it in the terminal. This is my simple Flask application doing nothing fancy. If you understood this, very good. If you didn't understand this, it's fine, because you do not need to understand the Flask code. You just need to understand that you have built the Flask APIs. Currently, I know Fast API is very popular, but that doesn't mean that you do not need to understand Flask API. Flask API is the basis of all the APIs that you can understand in Python. This is my interpretation. Okay, cool. So we have this app.py, the code that we want to run, and we have requirements.txt as well. Perfect. Now I will create the Dockerfile, because I want to run this application in the Docker container. Okay, so I'll simply say Dockerfile, and same thing. I will say from, because I want to use same image, pull base image for Python from 3.8 slim. Let's use the same one. Then set the working directory. You already know app. Now there's one thing. Now you will copy requirements.txt as well. Why? Because see, whenever you want to build any application, specifically let's say this one, you would need to install all the libraries which are in the requirements.txt file. Then you will just download it, right? Install it. But before that, you need to have that requirements.txt file in your container. So now there are two options. Some people prefer this way, copying everything. Copy the current directory app and the image, copy dot and app. This will move everything. Make sense? It is like a quick way of doing it. Okay. Some people say I will first install the requirements.txt. Okay. Copy the requirements.txt in the app. And if you just copy this, you have to put the requirements.txt here as well, so that it will be just saving the file with the same name. Okay. So some people say I will do this and I will install the libraries, run pip install -r requirements.txt, because that's what you run whenever you want to just install anything. If you have worked with Python any time, you need to run this command, run pip install -r requirements.txt. You need to run this. Any doubts? Okay. Any? Good. But I will also add one flag. It's called no cache directory, so that it will not cache anything and it will just install everything again. Okay. And I will copy the rest of the stuff. Copy.app.this. Now this is one way of doing it. This is just the one way of doing it. There is another way to do that. What is that thing? So see, the other way to do that is you can simply copy everything in the app container, like app basically folder. Let's say dot and then app. So if I say copy everything, copy everything from the current directory. So I'll simply say copy dot and then app. Simple. Will it make any difference? No, obviously no, because I will have requirements.txt as well when I'm just running this command, and I will have this file ready, and I can simply say run this thing, pip install -r requirements.txt. This is a simpler way of doing it. If you just want to do that way, it is fine. If you just want to go other way, it is fine. And you can do also one more thing. You can also write this dot. What does it mean? Just read it. You already know the answer. Dot means current working directory of your host, this one, and other dot means destination, the current working directory of the container. Now you already know when I say that I want to set my current working directory, and I already told you that whatever we write after this command will be done, will be executed within this folder. So what is my current working directory? Obviously it is app. So I do not need to specifically tell it, hey, paste everything in the app, paste everything in the app, paste everything in the app. No, I can simply say dot. If you want to specify another path, let's say I want to say app and then I want to say code, that is a different story. But if I just want to put everything in the same directory, I will simply say dot dot copy dot dot. Simple. Saves a lot of time. Okay. Then let's finally run the application. Python app.py. Perfect. So far so good. Let's try to build this image and let's see if there are any errors. I will say cd projects and then to Flask app. Okay. And then now let's say Docker build -t, and this will be like Flask image. Cool name, Flask image. Okay. Let's hit enter. Oh, we forgot to add dot. Okay. So just say dot just to tell the location of the Docker file. So now it will build the Docker file. Perfect. So see, it is installing everything. Wow. So see what it did. It did 4 steps. That means it performed 4 layers. Okay. It made 4 layers. The first layer is it pulled the base image 1. Okay. Then it created this directory. Then it copied everything and then it ran this command as well. That means whatever we are doing here in the requirements.txt, like run everything, it will be done in the image. That means all the dependencies will be in the image. It will not be in the container. It will be in the image itself. Make sense? See, it ran this command and all the libraries, in our case, it is just Flask. So Flask library is there in the image. Because see, we do not have any container. We just have one image, Flask image. Now we will run the container. Okay, let's try to run the container. If I say Docker run name and I will say Flask container. Okay, and which image I want to run? I want to run, let's say, Flask image. Perfect. And I do not want to run it interactively because when we run the application, it by default opens everything interactively because you know when we run the application, it will be sending logs. So it's fine. Hit enter and it will say ddocker. Okay, I added double D. Perfect. Hit enter and it has started running our application. Wow. 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 Just click on this application. Click. Let me just click it. If I, so here is my Google Chrome. So it will say refuse to connect. Why? This is just a simple application which is running on my local host. Okay. This is a local host. Why it is not running? If I click here and if you just want to open it, you have 2 options. You can either press Control and then click your left mouse key. It will open this. And we have an error, that's why you are seeing this. Okay. And if you just want to open it manually, you have other option as well. You can simply go to, let's say, just simply search localhost colon and 5000. When you hit enter, you will land on the same thing. So both are same stuff. Okay. But why are you seeing this thing? Why? Here comes the concept of port mapping. So now the thing is, you have the local host port for Flask is 5000. Perfect. Let me just actually explain that stuff. So you have the port as the let me just explain. Okay, so let's say you have the port. So this is, let's say, your local machine. Local local. Let's say you have the local machine. Okay, this is local host, or let's say local machine. Okay, perfect. So this is a local machine. This is fine. Now this local machine has a port, let's say 5000. Let's draw a port here. Port, say port. Let's use, yeah, this one. So let's try to create a port. So there are so many ports in the machine, right? Makes sense. There are so many ports. Okay. And let's give a cool background. Let's try to use this one. Okay, simple. So this is a port. Makes sense. And let's try to use a good background here. Perfect. Makes sense. So let's say this is your local machine. Wow, cool. So let's say this is your local machine. Makes sense. And this is a port. This is the 5000 port. Makes sense. Now this is the 5000 port, okay, which receives to the application that you have built, local machine. Now you have the container running. So you have the container here. Okay, you have the container. Let's say this one. Okay, so now you have this container. Okay, makes sense. Good. Now you have this container running. Now this container also has this port, and it's also called 5000. Okay, it's also called 5000. Now this 5000 port is isolated from this one. Okay, this 5000 port is isolated from this one. Makes sense. Now you need to connect it. This is called port mapping. You need to say whatever you have in the port 5000 in the container need to be available. Need to be available in the 5000 port of the local machine. Makes sense. This is the port mapping. Now you need to do the port mapping. Make sense? So I can simply expand it and let's try to port map. So how we'll just port map? You will simply do like this. Where is the one? Okay, like this. Let's use white color. Okay, perfect. What is this? Okay, arrow type, let's use this one. So now you need to port map it. Yes, perfect. So now you will port map this port with this one. Oh, okay. Makes sense. You will simply port map it. You will simply say, hey, I want to port map this with the 5000 on the local machine. Makes sense. Or I can do it like this. Let's say, okay, perfect. Now let's attach it. I'm doing all this hard work just for you so that you can enjoy the notes. So see, this is the port mapping. That you need to understand. Make sense? Okay, good. So this is the port mapping that you need to understand. Okay, makes sense. Okay, so everything is running in your local machine. I know that, but containers port 5000 is different, is isolated, and yours is isolated. So you need to port map it. Make sense? Very good. So how we can just do that? It's very, very simple. So you need to run the container. First of all, let's kill the current container. Let's try to kill it. I am just deleting it from the, you can say, Docker desktop. So now it is done. So now I will run the same command, but this time This time I will add a port mapping. I will simply say docker run dp, and I will say P is for port mapping. Okay, P is for port mapping. I will simply say port mapping 5000 of my local machine should be mapped to the 5000 of the container. Okay, let's try to run this now. Same command, nothing changed. Now if I go here, okay, if I go here, I will see my Flask app is running. Hello Flask app is running in Docker. Wow. Okay, this is running in Docker. Very good. And I have so many endpoints. I can simply go to about section and contact section as well. I can just show you. If I just go to this particular route, I will simply say contact. I will say contact us at ABC. If I say about, I will see this. So this app is working fine now. Why? Because of port mapping. And port mapping is very important. You cannot eliminate this. And if I go to Docker container, if I just go to containers, if I click here, I will see everything in the like logs in the Docker container as well. And if I just go to files, I will see everything here. See, file has app.py, Dockerfile, requirements.txt. And I've already explained everything regarding this thing, like why these folders are here using read only layer and writable layer. Makes sense? Very, very, very good. This is a common Flask application or common endpoints that you will also build. Okay. So that's how you can build. That's how you can build. Make sense? Make sense? Make sense? Very good. And I'm happy that you're learning all of these stuff. Okay. So now we're gonna level up. We're gonna use multiple services. Okay. And we're gonna also talk about networks, like why networks are important and what is network and how we can just take care of all those things. But if you are learning and enjoying so far, just drop a comment in the comment section and we're gonna talk about so many stuff as well very, very soon. So let me quickly stop the container. I can simply say docker stop Flask container. Okay. And let's say remove as well. Docker remove Flask container. Perfect. Okay, perfect. So now let's talk about the Docker networks. Okay, let's talk about it. First of all, I want to know that why do we even need the networks? Why? Especially in Docker. Why? So see, Docker networks, right? Even before discussing what are Docker networks, you need to understand the problem again. So see, whenever you want to understand anything in Docker, always start with the problem it is trying to solve. Okay. By the way, Docker is not trying to solve any problem related to networks, but if we want to work efficiently within Docker, we need to manage the networks. Okay, makes sense? Very good. So let me just open the Blackboard. Okay. So let's now try to discuss. By the way, I just changed the colors here. Now it looks good. The earlier version was like a little bit blurry. So now I think it's good. Okay. Makes sense. So now what we're going to do, we're going to talk about networks. Okay. So let's talk about networks. So for example, we are trying to build an application for data engineering where we need to use multiple applications. Within one application, we want to use multiple applications, or you can say we want to leverage multiple technologies. Okay. So in our current scenario, what are we going to achieve? We're going to simply build an application for Flask. Okay. Makes sense. Okay. So let's build this Flask application. Okay. Perfect. Okay. So this is Flask application and we saw like how we can just run this. And this is container A, by the way. This is container A. Or let's say Flask container. Okay, makes sense. Simple, nothing special. Nothing special. Okay. Now we want to make our application more dynamic, or you can say more robust and more real time, where we want to talk to some other applications as well. For example, I am building an application for my data engineering ETL pipeline, where I also want to store some data to, let's say, MySQL. Common scenario where you just want to store some data in the MySQL. Makes sense? Very common scenario. And I will call it as, let's say, MySQL. MySQL container. Makes sense? So now let's say the situation is this has some endpoints. Okay. This has some endpoints. When I hit a particular endpoint, okay, let's say if I hit an endpoint. So let me just draw, let's say you, okay. Let's say you are using this application. Okay. You are using this application and you will hit a particular endpoint. What will be the endpoint? The endpoint, let's say, will be, for example, anything. Let's say it hits get, or let's say store data. Okay. Makes sense? Store data. There's an endpoint, right? It can be there. Okay. Makes sense. So there's an endpoint called store data. So when this person tries to hit this endpoint, what will happen? According to the logic, this Flask app will do, or basically run the function. Okay. And this function will do what? This function will try to put some data, okay, to this MySQL database. Okay. Okay. Makes sense. Makes sense? Good. So this is the current architecture. It will put some data. Perfect. When this person will hit this endpoint. So this is the current architecture, but this is not allowed. What? Yes, this is not allowed. Ansh, we will define our logic in the application. It is allowed. We can do that. No, it is not allowed. Why? Because this Flask container cannot talk to this MySQL container. Why? Because both are running on the different network. So let's say this is a network. Okay. This is a network called, let's say, network A or whatever. Okay. So this is a different network. And let's call it as network A. And this particular container is running on a different network. Okay. Let's say network B. So both are running on a different network. That is why they cannot talk to each other. Okay. They cannot. Make sense? So now the communication is not allowed. Okay. In order to solve this problem, you need to do one thing. You need to first of all need to create a network, common network. Okay. So this is a problem, right? This is the problem. This is the problem. Okay. Now what is the solution? Solution is very simple. What are you going to do? We will run our application within the same network. Okay. Basically run both the containers within the same application. Let's say, let's remove this one. Perfect. Perfect. Now this is allowed. Now both are running on the network A. Now they can just talk to each other. That is the whole concept. That is the whole concept. Make sense? Simple? Yeah, now it's simple because you saw the problem and you saw the solution. But here it is not allowed because each container runs on the individual network. Make sense? Okay. Makes sense. If we just try to look at the definition, you will find that whenever we create a Docker container, Docker automatically assigns it to a network called bridge network. So let's say you are running the container for Flask. It will be assigned a bridge network. If you're running MySQL container, it will be assigned a bridge network. So now let's say you have multiple containers running. Obviously, each container is isolated from other by default. This means they cannot communicate with each other because they are on different networks. Simple. Got the point? Got the point? Okay. Ansh, Lamba, how difficult it is to create the network in Docker? To be honest, it's very simple. The steps are very, very simple. But yes, you need to be very, very careful, because if you miss anything, you will see the errors that will be like next to impossible to solve. Why? Because you will not actually realize like where the mistake is. Okay. So now what we're going to do, we will bring our VS Code editor and we will create a new project called, Flask app network, or let's say Docker app. And yes, in this particular example, we're gonna go one step ahead. Okay, we're gonna use MySQL container as well. It will be fun. It will be like lots of learning for you. Okay, so what we're gonna do, first of all, let's create two different folders within the Docker app network, because we want to do two things. One is your Flask application development, and second thing is MySQL container, right? Okay, so in order to do that, you can create two different folders that I personally like. You can create one folder as well, it's fine, but if you keep the separation layer, it will be very good for you, and this is my way of doing it as well. Make sense? Okay, so now what we're going to do, we will simply create the MySQL folder first of all. Okay, makes sense? Makes sense? Very good. We're going to create MySQL container. Okay, so now let's create this, like let's create a folder within this. I will say MySQL. Perfect. Within the MySQL, I will create Dockerfile. Okay, so now what we are trying to do, we are trying to create a Dockerfile to build the MySQL image. Simple sorted, simple sorted. Okay, now how we can just pull the image, you know, you can just go to DockerHub. I can just show you again. Just go to DockerHub. Okay, and here you can search MySQL to just see the available image. Search here and just click here, MySQL. Perfect. And here you will see tags. Usually you can use any of these tags. Okay, there are so many versions. I will be using 8.0, MySQL 8.0. Okay, you can use anyone if you want. Make sense? There are so many available. Okay, so let's try to use 8.0. So I will simply say pull the official MySQL image, and MySQL 8.0 is very popular as well. Then we need to do one more thing, which is called set environment variables for MySQL. If you have ever worked with MySQL, you would know that we need to create user and password. By default for MySQL, the user is root, so that is fine, but we have to create the password, right? Very good. And usually we also create the database as well that we want to create for our MySQL server. Makes sense? The same thing we need to do it here as well. Same thing. Okay. So now what you can do, you can simply say set environment variables. So I will simply say MySQL root password. Okay, MySQL root password. What is the password? I can simply put anything. Let's say demo password. Simple. Then I will say MySQL database. Okay, and I will call it as, let's say, demo DB. Make sense? How do I know? By the way, I need to put env as well. How do I know that I need to pass these variables? Again, everything is written in the image description. Let's say I open this one. If I go in the overview tab, because in the overview tab, you will find all the information, like how to use the image, how to pass the environment variables, what are the possible environment variables available. So if you scroll down, you will find it everything. If you read it, if I search, let's say environment variables. Okay, so here you will see environment variables. So we need to pass environment variables like this. Make sense? What is this thing? This is a kind of Docker Compose file that we'll be just talking about very, very soon after this section. But for now, we are not using Docker Compose. This is just a Docker file that we are trying to use, but environment variables will remain the same. Make sense? Very good. Very simple thing, nothing fancy. So we have simply passed the variables. Now, in Docker, you will say Ansh Lamba. Let's say we are trying to run MySQL database, basically MySQL server. Is there any way that we can also initialize the database while running the container? Is it possible? Yes. Let's say you want to create a database, okay, and you have already created it. And you want to also create the table as well. Like you want to run a personal customized script while initializing the container. You have the liberty to do that. Wow. So I'll simply say copy the initialization script to the Docker image, or you do not need to copy. Okay. So I will simply write this thing, what I have just done. So I have said copy init.sql. Where is init.sql? There's no init.sql for now, but I will create one. So I will simply say copy this file to this particular location. Now what is this location? Docker entry point, Docker -entry point -initdb. Whenever you create a MySQL container, there is a folder called Docker entry point initdb.d. Docker container will create, or basically will run everything which will be there inside this folder. So this is a default folder which will be there. I will show you when we will be just running the container, but it will look for any file. Okay. What if I do not pass this? Let's say if I do this, what will happen? Nothing will happen, because obviously folder will be there, but it will not find any script. So it will not initialize any table. Oh, but if you want to initialize your table, then you can simply say copy. And here you need to create init.sql inside MySQL folder at the same level where we have Dockerfile, init.sql. By the way, don't worry, I will just push this whole code base to my GitHub. You can simply use it. Okay, chill scenes. Okay, so init.sql. Make sense? Okay, good. Init.sql. So in this init.sql, I will simply write a simple command, create. First of all, I will write use, because I want to use the database. Okay, MySQL fundamentals. So DB name is DemoDB. Okay, let me close all the other tabs that we are not using. Okay, perfect. So use database, this one, and then let's create a table. Create table users, name and email is there. Okay, let's try to do this. Or even if not name, let's try to put, let's say, city and temperature. Okay, why? We will create a table for weather API. Okay, so I'll simply say city varchar not null and then temperature. Perfect. Make sense? So let's save it. So now what will happen? This whole script will run when it will initiate this particular container. Make sense? Okay. Now we also want to say expose the default MySQL port. What is the default port for MySQL? It is 3306, but I will expose 3307. Why, Ansh Lamba? Because I already have 3306 port for my MySQL server, because in your case as well, you would have downloaded MySQL server. It would be on your machine, but if you have that MySQL server, it can create a conflict. Okay, and I do not want that, because you will say, I'm not running my MySQL, why it will create conflict? Bro, even if you are not running it, it is running in the background. You can just check it. And sometimes it can create the conflict. So I will not expose my 3306, which is my personal on-prem MySQL server. I will expose 3307, okay, because I want to use the MySQL server running in the container. So is it possible? Can we do that? Yes, but we need to specify in the port mapping, and I will do that. Okay, so whatever you write here in the expose section, it will not directly expose it. It is just for the documentation. So real port mapping will be done during the container creation. Make sense? Very good. So now what I'm gonna do, I am gonna build the image. Okay, let's try to build the image, because I think everything is fine. You do not need to worry about anything. Okay, so let's try to build the image, and you will actually see the code, everything in the Docker container as well, like Docker desktop as well. Okay, so let's try to do that. I will simply say cd projects 3 Docker app network and then MySQL, because I have my Dockerfile in the MySQL, but it's fine. Even if I stay there, it's fine. So I just need to give the location while creating the file. Make sense? Okay. So I will simply say Docker build and then T, and I want to name it as, let's say, MySQL image, and the location is here, MySQL / dot, because it is inside the MySQL folder. Okay, let's hit enter. Let's wait. The system cannot find the file specified. Which file? init.sql is there. Oh, okay, makes sense. So what are we gonna do? Init.sql, I think it is there. Okay, what's wrong? Docker build t MySQL. Okay, http ping open desktop Linux engine. The system cannot find the file specified. Which file it is talking about? I think everything is fine, but still, because it is not related to anything technical. Oh, wait. I think I didn't turn on the Docker desktop. Okay. Yeah, it needs to be on. Okay, let's wait. Let's wait. Let's turn it on. I think it can be a problem. Okay, because I don't think so it's anything else other than just like running instance of Docker. But yeah, let's see. Let's wait for it to run. Okay, now it is running fine. As you can see, starting the engine. Yeah, Docker engine was not running. So now let's try for one more time. Oh, perfect. That was the issue. Yeah, I knew it. So now you can see that it is now pulling that MySQL image from the DockerHub, and it is running our init.sql file as well to create the table, and you will see everything. Don't worry at all. I will show you everything. Wow, it is doing okay. What is it saying? Legacy key value format. Okay, env key equals value. Okay, should be used instead of env key value. Oh, okay. Oh, wait. So they are saying, so it is not a, by the way, error. It's just a warning, but this warning is really cool. So it is saying legacy key value format environment key equals to value should be used. So yeah, I'm using this thing instead of legacy. This instead of double quotes. Okay. Instead of env key value. Oh, okay. So why it is giving me warning? Because I'm using the modern format, right? See, I'm using environment key equals to value. So I'm not using environment key value. I'm using equals to sign. Okay. Secret value, do not use arg environment for sensitive data. Yeah, I know that. Okay. So by the way, we do not need to worry at all. It's running fine. So if I just show you the images, you will see this image is running, like not running, but it is created MySQL image. Okay, and it is of 1 gigs. It is a big image. I know that because SQL servers are huge. So now what will happen? We need to turn on the container. Obviously, we need to run the container. So now let's try to run the container. So I will simply clear everything. So I will simply say Docker run. Okay, so now here comes the part. We need to do the mapping. Okay, so I will simply say DP 3307 should be mapped with 3306. Remember? Ansh, Lamba, why did you use DP? Because earlier we used P. So see, you can use P as well. It will work fine. When we use DP, D means detached mode, so that your terminal will be free. Otherwise, you will see a lots of logs for your container, and you do not want that because you want your terminal to be free to be used. So you always say DP. It's a good practice. Okay. So this is done. Let's give a good name. I will simply say MySQL container. Okay. And what image you want to run? MySQL image. That's it. Make sense? One thing we need to make sure, what? We need to run this container in the network. Oh, okay. Yes. We need to run this image in the network. So before even creating this image, we need to first of all create the network. Make sense? Make sense? Make sense? Yes. We first need to build the network. Okay. So what if we do not build any kind of network? So see, if you do not build any kind of network, then you will not be able to talk to any kind of Docker, or you can say container. Make sense? Makes sense. So first step is creating the container. So let's remove this like everything and let's run Docker network create. And I want to name it as, let's say, Ansh network. Okay. Hit enter. Network with name Ansh network already exists. Wow. Let's see whatever networks do we have. We have Docker network, I think ls. Yeah. Oh, so we have so many networks. See, bridge network, host, none, and so many other things. These are basically the default ones. And this is the customized one that I've created. Okay. And let's delete this Ansh network because I want to use it for this purpose. Okay. So I want to basically create a new one. I can either create a new network, okay, with a new name, but I want to search for the command delete network in Docker. Docker network, remove network. Wow. Okay. Remove and then network name. Okay. Let's use this just for fun. Just for fun. Okay. Just for fun. Nothing to worry about anything. Okay. So I will simply say Ansh network. Okay. Okay. Makes sense. So it is done. Now let's create a new network called Ansh network. Perfect. So now this network is created. If I say network ls, so Ansh network is here. Very good. Now we need to run the container and we need to attach our container to it. Okay. So let's try to run this command. Okay. Network run, and here everything will be same. Will be exactly same. We just need to pass the network parameter. That's it. Okay. And after name, so I will simply say network is Ansh network. That means you need to run this container on this particular network. Hit enter, and this is now running. Hey, what have I run? I have run the Flask container. Oh, so sorry for that. Okay, so let me just stop it. I didn't realize that I am running that command. So let me just delete it. Okay. So I have deleted it. Let's try to run our SQL container, not Flask container. Okay. So yeah, this is the command. Where is the command? Where is our command? Oh, because we never ran that. We never ran that command. Okay. So let's say Docker run dp 3307 3306 name MySQL container. Okay. And network Ansh network. Okay. And you want to run MySQL image. Hit enter, and now it is running. See, this is the running. This is the container ID. Perfect. If I bring the Docker desktop, you will see the containers, and this is here. Now, why it is not running? See, I cannot see green sign. Why? Why? So the reason is, even if I just say, let's say start, it will start and it will immediately stop. See, it will start and it will immediately stop. So this is a problem. Okay. This is a kind of issue that you need to resolve. And let me just show you the error. If I open my Docker desktop, if I click here in the logs, you will see the error. It will say you need to specify one of the following as an environment variable: MySQL root password, MySQL whatever. You will say, bro, we have defined the environment variable C. So why it is complaining for that? There's a typo. We used underscore and we cannot use underscore in this. Make sense? Make sense? So we cannot use underscore. So what we need to do now, we need to rebuild our image. Okay. Because earlier image was not the correct image. So let's delete it. and we cannot delete it. We first need to delete the container because it was used by the container. Now we can just delete both the things. Now we need to build the image again. So I'll simply say Docker build this image. This image is built, as you can see. Okay. Now what we need to do, we need to rebuild the container. Run dp mysql, perfect. Let's run this. Okay. Now let's see. Now if I bring the containers, now it is green. Now it is up and running. Perfect. So this container is running, right? This container is running. That means our MySQL is running. Wow. Do you know this MySQL is running on your machine? Okay. How you can just validate it? There are two main sources to validate it. First is if you have MySQL Workbench. I have MySQL Workbench. So I will simply open MySQL Workbench. If you have, it's good. If you do not have, do not need to worry. I will just tell you the other way as well. So what you need to do, you need to simply go to plus button. Okay. Just to set up the connection. So I can just show you the connection details. So if I just say edit connection, you need to put host name as 127.0.0.1. Then port is 3307, not 3306, because you are not using 3306 of your machine. You are using 3307 of your machine. Make sense? So whatever 3306 port, let me just show you, bro, if you forgot it. So remember this port mapping. So now what is happening? This port is called 3306 of the container. It's fine, but you are connected here on the 3307. So you need to connect it to 3307. Make sense? Very good. Very, very, very good. So here, if I open this, you will see that we have 3307 and username is root, and it will just ask you for the password. You can just put the password that you have created here. Demo password. Make sense? So now let's try to test it and it should run fine. Oh, failed to connect it with user root. Okay, unable to connect. Okay. So what is the username then? We will see. Don't worry. Let me just hit this particular endpoint. Not connected, not connected, not connected. Okay. So what is the username? I think user is just root, I guess. Root. Let me just check. Oh, this container is not running now. What's happened? What's happened? Unknown database. Okay. Oh, creating database, demo DB. Okay. Unknown database. Okay. So I think nothing is wrong. Something is wrong on the script side. Something is wrong on the script side. Okay. So if I just open the database. Okay. So here I can totally see the error, and I didn't make this error. This copilot made this error. It said use database and then database name. We never write this thing. Never. In SQL especially. We simply say use and then database name directly. Make sense? We never do this. So again, we need to do what? We need to rebuild the image. And by the way, I am happy that we are seeing these errors because I don't want to give you the false hopes. Whenever you just work with Docker, you will say, hey, why I'm seeing so many errors? You will see the errors, so many errors when you are just working with Docker. Not with Docker, whenever you're just developing anything. Make sense? But with Docker, yes, because you do not know like what's actually being built in the image. You run it and then you get to know. Make sense? So I can simply rebuild the image. And this time, let's hope everything is fine. And let's run the Docker container. Perfect. And let's see everything is fine. Let's bring this thing here and containers. It is running fine. Okay. Stopping temporary server. Okay. It is fine. Ready for setup. Start. Okay. I think it's fine now. MySQL int process done. Ready for startup. Very good. Now let's try to use our SQL Workbench. Okay. Now don't worry. Even if you do not have SQL Workbench, I will just tell you how you can just do that. So first of all, let me quickly test the connection. And here it is asking for the password. I will simply say demo password. Okay. So it is saying successful. Now I can just open this. Now you will see. So this is like the command previously that I ran. So you can just ignore it. If you see demo DB, it is already there. And we have the tables as well called users. See, and we have the columns as well. Wow. If I just try to query it, I can. So let's say, I know it is empty, but still I can just query it, right? So I will simply say select asterisk from, why it is like blur here? Okay, it's fine. Select asterisk from users. Okay, if I run this, no database selected. Obviously we need to double click here and then run it. Demo db.users doesn't exist. What do you mean? Select asterisk from users. Okay, because users is, yeah, perfect. So now we have this table. It is empty. Why? Because we didn't insert any data. Okay, but we can insert now. It's not a big deal. But yeah, we do not want to insert the data. We just wanted to create the table. Make sense? Okay, very good. This is the one way of testing it. Let's say you do not have the MySQL workbench, you can install it. But if you do not want to install, don't need to worry, because you do not need actually a SQL workbench to test it. Really? Yes, you do not need it. If you just want to run something, I can just show you what you can run. You can just go to your container, okay, and just run Docker execute, okay, in the interactive shell, and then your container name, okay, and then you simply need to say u, that means username is root, and then you need to say p, that is password, and just hit enter. Do not enter the password, just hit enter. Then it will automatically ask you for this thing, like what do you want to do? OCI runtime execution failed, unable to start container process execute, executable file not found in path. Yeah, we know that. Just write here MySQL. Silly mistakes, we know that, but it's fine. Just hit enter. Now it's fine. Now it will ask you to put the password. Now you can just put the password. Just remember one thing, even if you type, it will not move, like this cursor will not move, but it has written the password. Okay, so you can just trust it and hit enter. That's it. So now it is saying welcome to the MySQL. Do you know what it has done? It has opened the interactive shell for MySQL. Now I can literally do anything. Let's say I want to say show databases and semicolon. Hit enter. I will see everything. Demo DB, whatever. Now I will simply say use demo DB and semicolon. Perfect. Okay. Now I will say select asterisk from user semicolon. Empty set, but we know that we have the data, like we have the table here, right? So you can just confirm it like this. So if you are seeing all of these things, that means your SQL server is running. The only difference is that you are not using the UI to interact with it, but you are using the interactive shell. So that thing is confirmed that we are able to do the thing. We are able to write everything basically in the SQL. Make sense? Okay, so that means SQL is running fine. Now what we need to do, our SQL server is running fine. It is up and running. So now what we can do, we can now focus on the other part, which is called Flask application. So I will click here on the 3 Docker app network, and I will create a folder, and I will simply say Flask. Make sense? Good. Now in the Flask application, I want to create an endpoint. Okay. So I will simply say app.py. Okay. App.py. Okay. Now I want to just work on my Flask application. Okay. So I can simply say from Flask import Flask. Okay. Now let's try to create the endpoint. Okay. So I'll simply say app Flask name, app.route, def, return hello Flask. Now we will create a special endpoint. I will simply say insert data. Okay, insert data. So I will create this special function called insert data, and this route, what it will do, it will simply ingest some data. Make sense? Okay. I will simply create a connection because we need to connect to our database to insert the data to the database. Make sense? Like if you have ever worked with Python with MySQL, there's a library called PyMySQL, and there are so many other stuff as well that you can use. But for now, we are simply using the simple ETL, okay, data engineering ETL that you can build. Make sense? Okay. So now in order to work with this, what we can do, we can simply import PyMySQL. Okay. Import PyMySQL. PyMySQL is a library that helps us to connect Python with MySQL. Make sense? Make sense? Any doubts? Any doubts? Like simple PyMySQL is like just a library to connect your Python to the MySQL. Make sense? Okay. Now what we need to do, we will simply create a connection. Okay. And now in order to create a connection, you have like multiple ways. You can either create a function or you can directly create a create the connection. It's fine. Like it's up to you. You have the full liberty to do that. Make sense? Okay. So now I will create a function because I love to create a function to do a specific task. Okay. So what I'm going to do, I will simply say, bro, I want to create a function. So I will simply say def function name. So whatever, you can just see it here. Everyone, bro, just a simple Python function. What are you doing? Okay. So I'll simply say db connection, it's fine. PyMySQL.connect, return connection. That's it. So that's all you want. That's all you want. So it has created the connection. Yeah, that's all you want. That's all you want. This is your connection, right? This is your connection where you simply say, hey, this is the connection. Make sense? Make sense? Have you ever used PyMySQL to create the connection? So this is the way you create the connection. Okay. Or I can simply do everything within this route. It's not a big deal, but I just wanted to confirm like if we just can create a dedicated function, but it's fine if we can just get rid of this and we can store everything within this main function. It will be like user friendly, like it promotes readability. I'll simply say connect to the database and we do not need to return it. Okay. Here we need to take care of all the things. What is the username? Username is user. Okay. Very good. Host name is localhost, right? But we do not use localhost. Why? We need to use the container name, and I will tell you why. Just hold this for now. I will just tell you why. Password is our demo password. Okay. Database name is like, I think, DemoDB. Perfect. So this is my connection. This is my connection. Okay. Makes sense. Now I will create a kind of cursor. Cursor is just a fancy word, but it's, you can say, a kind of way to talk to the database. So I'll simply say cursor equals connection.cursor. .cursor is a method that we created. Okay. So create a cursor object, and with this object I can do so much of things. I will insert some data. I will write this query, insert into demo table. What is the table name? I think it's users. Okay. Okay. Insert into users. And then I will simply say values is sample data. Okay. But I don't want to do this because I want to write the original query. Okay. So how we do that? So I will simply say insert into users, and then we have like two columns, major columns that we have, right? If I open it, I have city and temperature, right? So I'll simply say city first and then temperature. Make sense? These two are the columns that I want to use to write the data. And for the values, do you know what I will do? I will simply use special characters. Why? Let me just show you first of all. Because we have percentages, and I will pass this data while using the function. Okay. Simple. So data write will be data write that I want to write. Let's say data. Data will be, let's say, New York and 25. Make sense? Simple. Data is like New York and 25. Okay. Now I want to say, I want to execute this query with this data. That means this is my query. And this is the data that I want to insert. Simple. And after this, I want to simply commit the connection and then close the connection after it. Cursor.close, connection.close. That's it. This is my endpoint. Make sense? Now let's try to run this. Okay. And we can return data inserted successfully. And then at the end, if name equals to main, this thing, and then port equals to 5000 and debug equals to true. This is our Flask application that we have created. Here we have the dependency as well. So let's quickly create dependency requirements.txt, and we have two requirements, Flask and PyMySQL. Okay, there's one more requirement. This is not used, but it gets used in the background. It's called cryptography. So whenever our Python tries to connect to the MySQL, it uses something called as SHA-2 cryptography, and it needs this module to use that. Okay, this is mandatory thing. Like you will see this error, only then you will get to know, okay, oh, this is a kind of error that we can just see. Yes, this is not like very obvious, but you need to just work with this. So are we ready to see the errors? Yeah, because if we run this, if we run something, we will see some errors, right? But it's fine. So our comments.txt is also fine. Everything is fine. Now let's try to run this and let's see what are the errors, even if there are some. Okay. So let me just create the Docker file. Perfect. We'll simply say pull the base image for Python. Let's use 3.9 slim. Okay. And let's use this one, and everything is fine. Copy dot. Okay, perfect. Now let's try to quickly build this image. Okay, let's try to say cd and then projects and then 3 Docker app network. Perfect. Now let's say Docker build -d and then Flask image. I think we already have one image with this name, so let's try to first of all delete that. I can use a different name as well, but I do not want to create multiple images right now. Okay, I'll simply say Flask image and location is this one. Okay, perfect. So it is building this image. Very good, very good. Okay. Perfect. It is done. Now we need to run the container. Okay. Now I know I need to explain like why did I use container name here instead of localhost. Don't worry. I will just tell you. So let's try to run Docker run dp. Let's do the port mapping as 5000 with 5000, same with name will be Flask app container. Okay, then most important thing, network. We need to use the same network where we have MySQL running. Okay, let's try to run this. Okay, this container is running. Let me see the containers. Okay, this app is running. Let me open that. Let me go to this particular host. Let's see if everything is fine. Okay, hello Flask. Wow, so this is running fine. Hello Flask. If I hit store data, URL not found. Hey, what is the URL? What is the URL? Oh, insert data, not store data. I was like, hey, why it is not working? Okay. Operational error, access denied for user using password. Yes. Okay. Access denied. Okay. I know about this issue. Very obvious. In just few seconds, I know what is the issue. So see, it is saying access denied for user. Obviously, the user that we have created is called root, is not user. Actually, yeah. So we need to correct this thing in our code. So how we can just do that? See, here we are using user. We need to use root. So let's try to rebuild the image and let me delete the container. Let me drop the image. Okay, let me just build this image for one more time. Okay, it is done. How quickly it has done that? Because it used caching. Okay, so now let's try to run this thing. Okay, now it is running. Now let's see if everything is fine. Okay, let's go to this thing. Let me just say insert data. Oh, data inserted successfully. Really? Let me just check. If I go to a MySQL, if I run this query again, I should see one record. Oh, wow. This record is there. See, that means it is running fine. Wow. We inserted the data using this. If I again hit to that URL, if I refresh this, it should, let me do it for one more time. It should insert 2 more records. Let's see. Perfect, man, perfect. It is working fine. Wow. So see, now we are able to do this thing with the help of network. If we would not have used network, our Flask application would not be able to communicate to the MySQL application. Make sense? Wow, this is amazing, man. Now I need to just tell you why did I use container name instead of localhost. So see, it is very important. Okay. So let's say you are running your Flask application. Okay. This is running inside the localhost of this container. So this is container A, or let's say Flask container. Okay. Similarly, we have MySQL container as well. Make sense? This is running in its localhost. This is running in its localhost. So now when I am using here host equals localhost, how it would know that I am trying to say localhost of MySQL container? Because this host is also localhost, right? Make sense? So how it would know this? So that is why we cannot use just localhost in the connection. When I say host equals MySQL container, that means the container name, Docker knows that I am trying to say the local host of this container. This is the internal DNS. Docker, let's say. So if I say this, let me just create the arrow as well. So this is equivalent to this thing. Make sense? This is called Docker internal DNS. That means domain name system. Docker internally manages this. So when I say host equals MySQL container, that means host equals to localhost of this. Make sense? Make sense? Make sense? This is the Docker internal DNS. Very good. I am glad now that you understood this concept as well. Now we need to talk about Docker Compose. What is Docker Compose? Because Docker Compose is that thing that is one of the most popular things right now. And you will get to know why. Okay. So now let's talk about the Docker Compose. Now what is this thing? See, in the previous chapter, okay, recently, we have learned how to make multiple containers to talk to each other using Docker networks, right? Makes sense. It works fine if you have, let's say, 2 containers, 3 containers, 4 containers, 5 containers, 10 containers. But think about those services, those you can say applications which talk to, let's say, 20 plus containers. Managing multiple containers individually can be really hectic and time consuming. What if I tell you that there's a way to manage multiple containers together as a single unit? Wow. Is it possible? Yes, with the help of Docker Compose. That's where Docker Compose comes into the picture. Now, for example, let's say composer. So you have this concept Docker Compose. Okay. So let's say you have multiple containers. You have container A, or let's say Flask container. Okay. You have Flask. Makes sense. You have, let's say, MySQL. Then you have, let's say, Postgre. You have Streamlit for front end. Okay. So there are so many containers. Okay. Now in order to do like work with these containers together, you would need to create a network, right? Like this. You would need to create a network. Make sense? Okay, you know this. You would need to create a network. And not only this, you would also need to attach each container to same network. So you will simply do it like this. Let's say like this, like this, like this, and like this. Okay, then only you can work with these containers. Okay, this is called Docker network. Okay, makes sense. What if I tell you that there's a better way to do it? I can literally create a Docker compose. So what will happen in Docker compose? I will take all these containers. Okay, I will take all these containers and and it's not just about creating the attaching the containers. It's not just that. Let me just expand on it. Wait. So let's say it's not just about attaching the container. So let's say now I want to decide the order as well. So obviously in order to run the Flask container, I first need to turn on the MySQL container because only then it can talk to it. Only then it can just create the connection. Remember, right? So this is my order number 1. Okay. Order 1. And once my MySQL is running, only then I can run, let's say Postgre. Okay. This is order number 2. Once the Flask is running, order number 3, then only I can run my Streamlit. Make sense? Because there's an order to run the application. Oh, first of all, MySQL should be running, then Postgre, then Flask, and then Streamlit. So you need to turn on these particular containers in the specific order. It's not just about the network. It's also about the turning it on. And just think about turning it off. You cannot turn off, let's say, MySQL first. You have to turn off Streamlit first, and then you can just turn off Flask. Then you can just turn off Postgre, and then you can turn off MySQL. These are just 4 containers. Think about if you have 20 plus containers. Think about it. Obviously, it is not feasible, right? So, Docker Compose solves all of these problems. It will say, I will take care of all the containers. So it will first of all create the network. Okay, that is the first thing it will create, the same network. Okay. Same network. And after creating the network, we will also take care of all the turn on and turn off together. So I'll simply define, let's say this is order 1. This is order 1. This is order 2. This is order 3. And this is order 4. So while turning on my particular Docker Compose file, I will just show you how you can just create Docker Compose file. When I'll be creating my Docker Compose file, I will literally specify the order in which I want to run my services. I can use a parameter called depends on, so it takes care of the lineage accordingly. So let's say I want to turn off all the containers. So do you know what I need to do? I simply need to say Docker Compose down. That's it. What it will do, it will turn off all the containers in the same order. If I say Docker Compose up, it will turn on all the containers in the same order that I have defined in the Docker Compose file. Just one command and all of your containers of the applications are synced. So powerful it is, bro. So powerful. You do not even need to manage anything on your own. So powerful. Make sense? Make sense? I hope you are getting the point. Like, so powerful it is. Okay. Now let's try to do this thing practically. Only then you will understand it. So let me just bring it and let's create a new project called Docker Compose. Okay. So let me create a new project called Docker compose. Simple. Okay, perfect. Within this, we're gonna do the same stuff. Okay, we will create 2 folders, and I can literally copy the folders from here. Okay, Control C, Control V. Perfect. Now within this parent folder, within the same level where you have Docker Compose, you need to create a file called Docker Compose. I think it's Docker compose.yaml. What was that? Oh man, I forgot the name. Wait, Docker compose.yaml. Perfect. So you can create this file called Docker compose.yaml. Make sense? Make sense? Make sense? Simple? Nothing fancy? Okay. When you create this Docker compose file, okay, and like it should be in the same directory, like the parent directory. Okay, parent directory, and you need to put hyphen, and oh, you need to just say d small. Perfect. Docker compose.yaml. YAML is a kind of format which is equivalent to JSON. Okay, it's very cool. It's a cool format. I love it. And you need to just take care of some indentation while working with YAML, and that's it. It's very easy to work with, and it is like more human readable, and it saves a lot of tokens in the AI world. So it is very, very good. Okay. We will talk about YAML in detail as well. If you want, just let me know in the comment section. We can just create a dedicated video on YAML. YAML is a cool feature that you should know. It's not a cool feature. Basically, it's a kind of format data type that we use with Python. Okay. Some people call it as like ain't markup language. Some people say it like yet another markup language, whatever you want to say. Okay. Okay. Sorted. So now what you need to do, you will simply start writing your Docker Compose file. One good thing with Docker Compose, you get the leverage, okay, to use Dockerfile or not. What do I mean? So as you know that for Flask application, we have this Dockerfile here, and we'll use this to build the image. But here for MySQL, I will delete it. Why? Because I do not want to use Dockerfile for MySQL image. I can literally pull the image directly from the DockerHub, okay, use the from command, and I can define all the variables that I want to define. Because if you would observe it clearly, if I just open this chapter, in this Docker file, we are not doing anything fancy. We are simply pulling the image and we are defining the environment variables. And we can define the environment variables within the Docker Compose as well. That's it. Now you will say, Ansh, Lamba, we are doing this thing as well. Copy init.sql. Yes, you are doing it. You are right. But that's not a big deal. Let's say you do not want to create any kind of table initially. So then you do not need to do anything, right? But what if you want to create? So there's a way you can still copy it with the Docker Compose in the Docker Compose YAML as well. But for now, let's say we do not want to initialize anything. We do not want to initialize any table. Okay. So in the Docker Compose, I will simply pull the image directly so that you will also know how to pull the image directly. Okay. So let's say Docker Compose. So I will start my Docker Compose file, and let me just close all the other things. Perfect. So I'll simply say within my Docker Compose file, so it starts with a kind of version. Now what kind of version? Like it can be anything. It can be, let's say, version 0.1, whatever you want to do, whatever you want. Let me just close this first of all. So let's say version, let's say 3.1, any version, it's like your choice. Then you need to define services. Now what are these services? See, I told you that in this example, I told you that we have these containers, right? In Docker Compose, we call each container as service. Each service is a container. Okay, cool. Okay. So each service is a container. Now, in order to define the services, just hit enter and just add 2 spaces. That's it. And then start writing the services. You can also hit tab, which is not like restricted, but you should always use double spaces whenever working with YAML. Okay. So now I will write my first service. Now what is my first service? My first service is MySQL container. This is the container that I want to make. Make sense? And here I will simply say image. I want to pull MySQL 8.0 Okay, and then container name. Now here's the thing, if you do not even pass this container name parameter, it will create a container name with this service name. But it's always good to pass the container name just to make it more readable. Make sense? Then you need to say environment. But before that, we always do one more thing, restart as always. Okay. And there's one more thing which is very important and which is something you will get to know if you are working actively with Docker. It says command default authentication plugin MySQL native password, because sometimes if you're working with MySQL, it uses that cryptography feature to just connect, or you can say connect it with your password, like use your password to connect it. Sometimes it can take a lot of time. Okay, so that is why we are saying do not do that, just use default authentication plugin. But the good thing is we have already defined the cryptography, so it is fine, but it is just a good practice to define it here as well. Then we can simply say environment, and here I will say MySQL root password is fine, and then MySQL database. Do not pass this user password again, it can create an error. Okay, so I'll simply say demo password and demo DB. Perfect, makes sense. Now we need to talk about ports. Ports, as you know, 3307 with 3306, if you remember. Very good, simple. Now we also need to do one thing which is very important, health check. Now what is this thing? So see, with health check, whenever we are just running the multiple containers, let me just show you. Again, this is the thing that you will feel or you will face when you are actively working with Docker. So let's say in my application, I have these two containers, Flask and MySQL. Okay, this is running as 01, this is running in 03, basically 02. Just for now, you can say 02. Okay. Now, yes, MySQL container will be running first, and then only MySQL, this Flask container will be running second. That is fine. But do you know what? If I say this container is started, doesn't mean that my SQL server is ready to accept the request. There's a difference, right? MySQL container can be ready in just, let's say, 1 second. But sometimes whenever we are just starting up our MySQL database for the first time, it can take some time, maybe few seconds. And if it gets connected to MySQL between that period of time, it can create errors. Okay, that is why we just add a health check. And what it will do, that health check will do nothing, but it will make sure that it will only go to the next service if this health check is completed. Okay, so we'll simply say test and then CMD, obviously CMD, and then you can simply say MySQL admin, and then ping, and then H, then localhost, and then you can also pass, let's say U, which is user, which is root, and then password. You can simply pass -p and then $, and then MySQL root password, which is this one. Makes sense? So this is a kind of health check. So now it will only go to the next service if this health check is done. We will allow interval as, let's say, 10 seconds. Timeout will be, let's say, 5 seconds, and then retries at least, let's say, 5. Make sense? Make sense? Okay, very good. This is service number 1. Let's create the service number 2, which is called, let's say, Flask container. Okay. Now for Flask container, we do not want to pull this image because we have to build this image. Okay. So I'll simply say, image, this thing. No, I will simply say build. Okay. And where is the location? Where is the location? Location is this one, right? Flask, and then dot. Make sense? See, I am here. I need to go inside this Flask folder, and then I have a Dockerfile. Make sense? Okay. Then obviously container name, Flask container, restart always. Simple. Then here comes the important part. Depends on MySQL container condition is service healthy. It will only start this container if the service health checkup will say healthy. Okay, and then ports will be 5000 to 5000. Simple, very good. And in our app.py we are doing nothing fancy, so everything is fine. This is our Docker compose file. Make sense? So now do you know what? Let me just delete all the containers if anything is running. And I will not even create any kind of network. Everything will be created by Docker Compose. Everything. So let me just delete everything. Okay. So now in order to run this, I will simply say, first of all, just go to that folder where you have Docker Compose file, projects, and then Docker Compose, and then simply say Docker -compose up, and then you need to say -d. D is the detached mode, and you have to put this, otherwise your terminal will be logged with the logs. Hit enter, and then you will see that it has started building all the images together, and it has also built the network. See, Docker Compose Flask container. This is the network. Okay, this is the network. See, default. We didn't create this network. You already know. Okay, this is the network which is already created. And see, currently it is waiting on MySQL container. Why? Because it is not healthy for now. Now it is healthy. Only then it was started. See, so it was waiting. It was waiting for 22 seconds. 22 seconds. Wow. If I would not have stated that thing in my Docker Compose, it would have right away connected. And if obviously MySQL server is not ready to listen to the request, it would throw errors. And you will say, hey, what is wrong? What is wrong? What is wrong? Now you know what was wrong. Now it is corrected. Very good. Now let's try to see the Docker desktop. And if I just go to containers, you will see only one thing. Ansh, Lamba, we created 2 containers. What is wrong? Bro, this is not a container. This is called Compose Stack. If I click on this drop down, you will see both the containers. Oh, so this is basically a kind of network. And within that network, we have 2 containers. Okay. If I click on this, if I go to this particular localhost, I can just hit to that link. And if I say insert data, okay. Okay, demodb.users doesn't exist. Very good. So why did we get this error? Because we do not have any kind of table created, right? We didn't create any table. Remember? We didn't create any table. So that is why we got the issue. But we can create the table. Really? Yes, we can create the table. We can, like how we can create the table? We can create the table using volumes. Okay, because we cannot use copy command here. Okay, but we can use something called as volumes. What are volumes? Do not worry. We'll just talk about volumes very soon. So in the volumes, we can just say, hey, copy everything which is here .mysql .init.sql, make sense, to this particular location. So what this volume will do, by the way, this is a kind of bind mount. So I have mounted this file which is inside this to this particular location. That's it. This is called bind mount. Oh, okay. We will talk about it. Don't worry, very soon. But you need to understand this. That is a kind of mounting. Okay. If I just try to rebuild it. So first of all, let me just say Docker compose down. If I write this command, do you know what will happen? It will remove all the containers. See, automatically, all the containers, all are removed. Now I need to rebuild this image. So I cannot use this Docker compose up. Why? Because it will simply turn on my containers. It will not rebuild it. If I want to rebuild my images as well with the container, I need to say Docker compose up build. Now it will rebuild my image. See, now it is building the image again. Oh, okay. Now you will be able to see the table because we have mounted our SQL script to the volume. Make sense? What are volume? Do not need to worry. I will just talk about it. It's a very simple concept. It's not a big deal, but yeah, it's important. We will talk about it. Okay. So this is done. And now let's try to check it. If I click on this, if I click here, if I click here, so I will simply say insert data. Data inserted successfully. Let's check. Let's check. So this is our okay. So if I click here, very good. We have one record. Why one record? because obviously this is a new database. The earlier one was deleted, and that is why the concept of volumes comes into the picture. I wanted to show you as well. So now this is a fresh database, so we just have one value. Make sense? Make sense? Make sense? Remember this. Remember this. Okay. So now this is also running fine. That means Docker Compose is also very well done. Wow. Docker Compose is also done. Now you know how to work with Docker Compose. Do not worry at all about this file. I will attach everything to the GitHub repo. Just go and copy and paste. If you want to copy paste, it's fine, because obviously you can just make mistakes if you're writing the code for the first time, but I would recommend you to just write your own code. If you see errors, only then copy and paste. Okay, good. By the way, I have just discussed so many real-time scenarios as well. Let's say about this, but yeah, it's good. About this, but that's how you learn. Okay, perfect. Now it's high time to talk about volumes. Okay, let's talk about it. So now let's talk about the storage layer in the Docker. Okay. So first of all, why do we need storage layers? Now you will say, see, whenever you build the Docker image, we copy the data, right? We copy all the code, all the libraries, all the requirements.txt, everything. Okay. So why do we need to worry about any kind of storage? Why do we need storage? Okay. So for example, let's say we might need to store data generated or used by the application. Let's say your Flask application is generated some logs. Okay. Or you have some data in your local system, in your host machine, and the data size is really, really big. You cannot easily copy it within your image, but you want to still use it while running the container. So in those scenarios, you would need to use something which can store your data. That's where the concept of Docker storage comes into the picture. Make sense? Make sense? Make sense? No, not completely. Okay, now it will make sense. Let me just pull up my Blackboard. So for example, and it is also called as volumes, or let's say, first of all, let's try to understand the concept. Docker storage. Okay, Docker storage. So now let's say you have an application, okay, or let's say you are running an application. Let's say you are running an application. Okay, let's say this is your Flask application. Make sense? Nothing fancy? Okay, good. So let's say you are running this application. Okay. Make sense? Okay, very good. So this is a Flask application. Okay. Now this Flask application has the code base, or let's say like this. Let's create the code base. Okay. So let's say you have the code, let's say app.py. Okay. This is app.py. And within that app.py, you have a folder called data. Okay. This is called data. Okay. And this data size, this has, let's say, CSV files that you're using. Now this data folder is too big. Okay. Very big, that you cannot include it in your requirements.txt, or basically not requirements.txt, your image, Docker image. Okay. You cannot do that. Makes sense. Okay. You can only and only move this thing. Okay. You can only move this thing, app.py. That's it. You cannot move this because this is very big in size. But now, obviously you want to use this data folder. So do you know what you will do? Let me just tell you. You will run a Docker container. Okay. Using this image. This is your package. Okay. This is your Docker image. So you will run this thing in the container. Okay. Okay. This is your container. Okay. Makes sense. This is your container. And now what you will do, you will bind mount it. You will bind mount, or let's say mount. You will mount this data folder from your local machine, to here. here, and this folder will be available in the container. This is called mounting. This is not available in the Docker image. No. This will be only available in your container. That's it. Wow. Literally wow, man. So this will not be the part of image, but this will be the part of Docker container. This concept is called as mounting, or you can say bind mount. Okay, let me just write it for you, because there are two scenarios: bind mount and volumes. Okay, so let's create two things. Docker storage. So this is called bind mount, and this is called volumes or named volumes. Same thing. Okay, volumes. Both are actually volumes. This is called as named volume. Okay, perfect. These are two different kinds of storage. So now we have discussed bind mounts, where we simply bind mount our local storage. Make sense? Nothing fancy? Yeah, it is fancy, but yeah, it is cool. Oh, leg. Okay, so this is bind mount. Make sense? Where we do not make the part of the folder that is in our system as a part of image, but we simply mount it to the container. Okay, so this folder will only be available in the running instance, not in the image. So it is our choice. It is our choice if we want to mount it or not during running the container. It is not the choice of the image. One thing. Very good. Now it's time to talk about volume. Okay, now volumes are almost similar, but what's so special about this named volume? So now what happens? Let's say, first of all, let's talk about the use case of it. So let's say here is you. Okay, and you are running an application. You are running, let's say, a kind of database. Okay, you are running a SQL database. Okay, SQL container. Okay, perfect. Now you know that whatever you do in the container will get saved in the folder, obviously, in the, remember that database folder? Okay, very good. Like it has some default folders, right? Similarly, it has a default location within this container. It's called var lib MySQL. This is the folder location, var lib and MySQL. That means var, then lib, then MySQL. Okay, this is the location where it stores all the data in the container. If I created some table, it will be there. If I inserted some data, it will be there. If I did anything, it will be there at this folder called var underscore not underscore slash and then lib, then MySQL. Make sense? This is a location. Okay, this is a kind of Linux location that you can just, I will show you, don't worry, I will just show you. So var lib and MySQL. Okay, so this is the location where it stores all the data. But the moment I destroy this, let's say I destroy this, what will happen? This will also be destroyed because this was just inside the container. Now if let's say tomorrow, or let's say after 1 hour, you want to run the MySQL container, you can run it. That's not a big deal. You can run it. But this thing will be new, right? This will be new. Okay, this will be new. So your data will not be there. Your data will not be there. Oh, okay. Your data will not be there. So what you can do, you can connect this path. Okay, let's say this is day 1. Okay, day 1, or not day 1, it's fine. Okay, so what you can do, you can, now you got the issue, right? Now you want to use something so that whatever is saved in this particular, at this particular path should be persisted. Should be what? Persisted. Okay, makes sense. Makes sense. Okay, so whatever is there will be persisted for the time being we are running the container. That's it, and after that it will be gone. Now what we can do, we can attach a volume. We can attach a volume like this. Let's say volume. Okay, this is volume. Now this volume is also residing in your local machine. Yes, it is also residing to your local machine, but you cannot directly connect to it because it is managed by Docker. It is managed by what? It is managed by Docker. Make sense? Make sense? But I can also tell you where it resides. It resides at this path, var, and then lib, and then not lib, I guess, I think Docker. Okay, and then volumes. Within that, your volume, whatever you name it. Okay, whatever you name it. So this is at your machine. This is your local host. Make sense? This is your local host. Local host, but managed by Docker. So you cannot directly use it. You cannot directly access it. You can only access it using the Linux commands. But it is in your local machine. So you will connect this thing like this. Like this. So you will do it like this. So now this location is connected to this volume. So now next day, or let's say after 1 hour, whatever, whenever you want to run the SQL container, but you do not want to run a new, like obviously you will be running a new container, but you also want to use the data that was created before. So what you can do, you can attach your new container with the same volume. Now what will happen? This container will also have the data, because data is persisted in the volume. It is no longer just be available in the container. So next day you can connect to this particular volume and you will see the data. This is a concept of named volume. I hope it makes sense. A little bit. Make sense? So this is the concept of volume. You simply connect it and that's it. And let's actually see it in the real time, then only you will understand it. So now let's try to create a volume while creating the container. Okay, so how we can just do that? So let's create a project 5 and this will be like very simple one. Volume. So we are not creating a bind mount, we are creating a volume. Volumes are like more used. So yeah, let's try to do that. And it will be like very simple one. So what we're gonna do, we will simply copy this MySQL folder and we'll just put it here. Perfect. So let's try to build this image first of all, because I have removed all the images. You can also remove it. Okay, everything is clean. And by the way, there is no volume here. Okay, I have some, I can remove it. Okay, so now what we're gonna do, we will simply quickly create the Docker file, or basically image for this. So I will simply say volume and then MySQL. Let me just clear it out first of all. Okay, so I'm inside projects. I want to go 5 volume. Perfect. What? This is here, bro. projects 5 volume. Volume is not recognized command line prompt. Are you serious? Okay, cd 5 volume. Perfect. So now I'll simply say docker build -t MySQL image with volume. Okay, then MySQL / dot. So it will build this. Nothing is changed actually, okay, because everything is there, and in the Docker file we have everything ready, so it will be there. Okay, very good. So what we need to do for now, nothing. Okay, so it will take some time. It takes, I think, 20 seconds around to build that. So yeah, okay, perfect. So now if it's time to run the container, I will simply say docker run. Okay, dp 3307 with 3306. Name will be MySQL container volume. Okay, now here comes the part how we can just define the volume. We will simply say -v. Okay, then we need to define the volume name. I will simply say Ansh volume. What it will do, it will create this volume for me. If it doesn't exist, if it exists, it will simply connect to it. Okay, for now we do not have anything, so it will create a new one, and it will map the the path. What is the path? Var lib and then MySQL. Make sense? This will be the mapping, and we need to basically run the image called MySQL image volume. Hit enter. Now this container is running. Perfect. As you can see, this volume is there, this container is there, and if you go to volumes, this volume is also there. Very good. Now if I will just show you something. If I open this, if I go to execute, if I go to, let's say, ls, I will see so many things, right? Now you just need to go cd var, then lib, then MySQL. Hit enter, then hit ls. You will see all the things are here. See, your demo DB is here. Wow. If I say demo DB, if I say let's say cd demo DB, if I say ls, I will find users.db, because this is my initialized command, right? This is the information that is within the container only. Okay. If I open the, you can say SQL workbench to insert some data just for the testing purpose, I can simply say currently there are no records. Let's try to insert it. Insert into users and values, let's say 1, and not 1, I think, let's say New York. Okay, and let's say 20. Perfect. Let's try to insert it. Perfect. Now if I say select asterisk, okay, if I, oh, why? Insert into users. Okay. If I run this, okay, columns count doesn't match at row 1. Very good. Because I didn't say 1. Now it's fine. Perfect. Now I can see 1 record. Very, very, very good. Okay, 1 record. And this is only created within the container. Very good. Now if I go to volumes, if I click here, if I go to, let's say, my volume name, where is my volume? I can just show you. It is inside MySQL. Really? Yes. I think it is Ansh volume. Yeah, Ansh volume. Within that I have MySQL. So all the things are here. Okay. And I think demo DB is also there. So users.ibd. So all the things are within this particular folder called Ansh volume. And this Ansh volume is within that location that I mentioned, which is here, if you remember, which is here, var lib docker volumes and your volume. Make sense? This is in your local host. Make sense? Very good. Now what I'm gonna do, I am gonna stop the container. Okay, or not even stop, I will simply drop the container. Make sense? I will drop the container. I will simply say containers drop. Perfect. Now container is dropped. That means all the data within the container is dropped, because container is dropped, bro. See, container is not there. That means all the database, all the table is gone. Right? If I run a new container now, if I run the new container, let's say I run this, okay, without the volume, okay, without the volume. If I simply run MySQL image volume, so I am running a new container, but I'm not attaching any volume. If I hit enter, if I see this, okay, this is running fine. Okay, if I connect it to my MySQL, what I will see, okay, this is not running. What's wrong? Let me connect it here. Okay, perfect. So okay, it is not running. It is running fine. Okay, this is running fine. Did we say port skip secret process done? I think it is running fine. Yeah, it is fine. Okay, don't save, just reconnect to it again. Okay, yeah, perfect. So now if I just try to query it, what should I see? Nothing, obviously nothing, because I have not done anything to this container and this container is empty, no data. But you know what, let me just show you the magic. I will again drop this container. I don't want this. Perfect. Now what I'm gonna do, I am gonna run another container, but this time I will attach this volume. See, because this volume is there. If you go to Docker desktop, this volume is there, Ansh volume. I will simply attach my new container with the existing volume and you will see the magic. Hit enter. Container is running fine. Now just go to this and just simply connect it again. Okay, connect it again. Oh man. See, I can see the data. Wow. Boom. This is the power of volume. Because now what happened? The same thing that I explained. Now this is the container. This one. This can see the data because data is here. It is here in the volume. So that's how you can persist the data for future containers. If you just want to keep it for your application, and the production scenarios, you create volumes so that you cannot, let's say, miss any data. Make sense? Make sense? I hope it makes sense. Very good. Now let's see how we can just push the Docker images to DockerHub finally, because now we are in the state, now we can just push our images so that others can use it. Okay. By the way, do you know what? I know this is the last section of this video, but I loved this video. I enjoyed so much while recording for this video. And why? There are so many reasons. One of the major reason is I know that this video gonna help you a lot. This video can just actually make a difference, because Docker is such a tool, such a skill that you need to know very well inside out. And I explained you so many scenarios, so many things, and I'm so happy. Okay, so last one. Okay, but yeah, we're gonna enjoy in this one as well. So now let's talk about DockerHub, or you can say push to DockerHub. Push to DockerHub. Perfect. So now what happens in this? So let's say we want to push the images to DockerHub. Why do we need to push it? So let's say you are a developer. Okay. Let's say you are a developer, and this time is a girl. Okay. So you have developed this thing. Let's say you have developed an image. Okay. Okay, makes sense. You have developed an image. Now this image is really cool and you want to distribute it. Makes sense. You want to distribute it. Okay. You can do it, obviously. If you just want to, let's say, do dev, QA, prod, you can do it, right? So let's say you want to say dev, or even if you just want to push it to QA, you can do it, right? The same image. Let's say you want to do it QA, it's fine. But do you know what? You can even push the images to the DockerHub. So that, see, now if you want to use images, how you are using it? One thing, you are building it locally using Dockerfile. Okay. Second thing is you are pulling the images from the DockerHub. You know that whenever we are just pulling the images and using our layers on top of it called Dockerfile, it needs to still be managed by us. We need to take care of Docker files. Sometimes we can just misplace it. So the best thing is we can push our Docker images to DockerHub for our ease as well. Or let's say we want to share our code with others as well. Or let's say we want to share our images to share our images with others as well, if they want to use it. Make sense? So it is very simple and it is very convenient as well. Let's say I want to push one Docker image, okay, for a simple Flask application, okay, and you can use it as well using the code that I will just show you. But for that, you need to have an account in the DockerHub that I just mentioned in the beginning of this video. So if you have not created that account, just go and create that account because it is very important. Make sense? So what I'm going to do right now, I will simply open my VS Code, okay, and here let's create a new folder. Actually, we do not need a folder, to be very honest, because we can pick any image. Let's say I want to push this image. This is a very simple image. Let's try to push it because there's no secrets, nothing inside it, no passwords and all. So let's try to push this image. Okay. So what I'm gonna do, I am gonna first of all remove all the terminals. So let's try to go to projects and then to Flask app. Okay. So I am inside this second Flask app. So now, first of all, I will build this image. I do not have the image. See, I do not have that image. So first of all, I will build the image. So how I'm going to build this image, this will be a little bit different because you cannot build this image normally. You need to build this image as per your username. So if I just go to Docker, if I see my username is Ansh Lamba, right? I need to build the image using that. So I will simply say Docker build, okay, Docker build -t. Now I need to use my username. I will simply say Ansh Lamba and then let's say custom Flask image. Simple. And I can also give a tag, let's say 0.0.1. Simple. I will build this. Oh, I forgot to add dot. Perfect. So now this will build the image and I can see that here as well. See, this is my image and tag is 0.0.1. Perfect. Now I want to push this image to DockerHub. Okay. First of all, it is optional step, but you can also do it. You can simply say Docker login. If you have not logged in your browser, it will ask you this thing that you need to log in. So you can just simply say Docker login and it will simply say login succeeded in my case. In your case, it will just prompt you to just go there and log in and it is fine. It is an optional step. It is not recommended. Like it is not mandatory, but you can still do it. Now the final step is you can push this image using Docker push command. That's it. That's it. But yes, you need to use the same image name. Image name is Ansh Lamba custom Flask image. Hit enter. And using default tag latest, tag does not exist. Oh, because I didn't give the tag. So it is saying 0.0.1. Perfect. So now it is pushing my image to the DockerHub. If I now open DockerHub, okay. If I open DockerHub, and if I just sign in, so here I am logged in into the DockerHub. And as you can see, if I go to repositories, I will see two repositories. One is for this Ansh Lamba Flask app. I think uploaded 2 days back. I was just testing something. And this is the one that we have just pushed it to DockerHub 1 minute ago. If I click here, you will see everything. What? You will see that I have this tag. Okay. If I click here in the tags, you will see that you can also pull this image using this particular command. And I'm not kidding. Let me just copy it and I will just show you how you can just pull it as well. If you want to use it, you can literally use this image and it will work. How? Just go to your Docker file. Let's say you are using this thing. Let's say this one. If I open Docker file, if we are using, let's say this one in our Docker file, if I go here, Flask, Docker file, app.docker file. So if I'm using from Python 3.9 Slim, I can literally use this thing. Ansh Lamba / custom Flask image and then tag name, and tag name is 0.0.1. You can literally use this image. Really, yes, you can use this and you can run it as well. Let me just show you if I want to use it. So what I will do, I will simply delete this image. Okay. and I will just show you how you can just build that. So let's say I want to directly run a container on top of the image that I want to pull from the DockerHub. Okay. So I'll simply say Docker run. Okay. Name, let's say hee, okay, just for fun. And if I say dp, okay, and I want to run it on, let's say 5000, and I want to pull Ansh Lamba, or I can simply copy paste it. Okay, I can simply say, I'm simply saying Docker pull. So I'm simply saying Docker run, and it will just do this. Let's try to run this. Unable to find image, so it downloaded it. That means it pulled it from the DockerHub. If I just show you my Docker container, see, this is running and this container is also running. See, hee, container name is hee. If I open this, you will see hello Flask app running in Docker. Did I create this file? No, I simply used it, right? And you can also do it. And see, do not make a fun of this particular Docker image. It is a very basic one, and I just did it for you so that you can understand the concept. Do not say, see, Ansh Lamba created this Docker file. Do not make a fun of this. I will not remove this at least for a few days so that you can also use it and you can also see it. But do not make a fun of it, okay? This is like a very basic example so that you can just see how we can just do it. Make sense? So this is a public view. Everyone can use it. Everyone can do that. And I'm still like thinking about the people. They will say, hey, see, Ansh Lamba built something. And then when they will just run this, they will say, hey, see. So yeah, that was all about this particular section. And you can say that is all about this particular video. I know you learned a lot of things in this particular video, and I am more than happy than you. Trust me, just because you learned so much in Docker. I loved recording this video. And if you want to learn more and more things, then this is the channel for you. This is the YouTube channel that is just teaching everything you want to know in the world of AI data engineering. And yes, I have some next steps for you. So next steps for you are very, very simple. You need to first of all master Python. If you do not already know, okay, Python is the backbone for AI data engineering. Second thing I would say, you can also watch something called as GitHub, because it is very important in the today's era. So for both the videos, like for both the topics, I have the videos ready. And this channel is the gold mine for you. Just scroll through the videos, or YouTube has added amazing feature in the channel. You can also search for a dedicated video if you want in the channel, and you will get that video regarding that topic. So in short, if you want to learn anything, this is a channel for you regarding AI data engineering, and just master everything and be in that 1% group. Makes sense. Okay, so I loved this session with you all, and I'm so happy that you all loved this session. Just drop a lovely comment in the comment section, and I will see you in the video coming on the screen right now. And happy learning.